All right, I'm going to go ahead and get started. You might have noticed on the screen that there's a little bit of a countdown, 3, 2, 1. Just want everyone to know that basically what I'm doing is I typically record everything that's on my screen when I go over any kind of Revit items, especially in building information modeling, and then also in this particular workshop. And I'll give you guys access to go back and review the video. So don't feel like you have to get every little thing that I go over. I know I'm going to cover a lot because there's a lot to pack into these Revit workshop sessions. And I want you guys to have the opportunity to go back and be able to review on the video. So I'll give you a website link up there on the board. There's jrodesign.com/Revit. That's my personal website that I use for posting this kind of information. And the username and password is up there as well. So if you guys just jot that down before the end of class, that would be good. And I'll eventually send out a link to where the video will be and all of that so you guys can review it. So before I get started on talking about Revit and then also getting into working in the actual software, I just want to make everyone aware that if you are a student or a faculty member, you have access to all the Autodesk software for free. So basically, if you can, you want to jot down, if you haven't already signed up, this particular website, this address right here called autodesk.com/education/free software. That will take you to where you can basically create an account, and then you can download essentially every Autodesk product that's available. And obviously, you'll want to download Revit, which I'll get to here in a minute, where I can show you the different versions. Again, you can always also just Google Autodesk Education Community. That'll usually bring you to the site. But if you want to take down that particular website, again, that's a good resource. That also gives you free access to the Autodesk Cloud. The cloud is where in Revit we render, so that you don't have to wait forever for your rendering to come back off of your computer. You can actually send it to servers up in some data center somewhere that basically renders your renderings in 15 minutes and gives it back to you essentially. Also, there's other cloud services that you'll be able to use, but we won't really cover those in this particular session. When you do get onto that website, over to the right, you can see here where it says sign in and create an account. That's where you want to sign in and do everything that you need to fill out your information. When you download your software, these are all the different software packages that are available. But when we scroll down, essentially there's different versions of Revit. So you'll see here there's Revit Architecture, Revit MEP, and Revit Structure. The difference is Revit incorporates Revit Architecture, MEP, and Structure. So it's basically everything. And if you're getting this for free, I would just go ahead and download Revit. Obviously, if you're purchasing this would be a more expensive package. But then these other parts are broken out for specific disciplines. So Revit would be the one you definitely want to download. And if you, for some reason, don't want to download that one, Revit Architecture obviously would be where you'd want to be. Also, when downloading Revit, and I'll give you a link to this a little bit later, but I've got this frequently asked questions on my website, and one of them is how do I know if I can install Revit on my particular laptop or desktop computer or so on. And it all has to do with your hardware requirements, and I'm not going to go over all the lists of what you need, but you'll want to visit this and actually look at the information because, number one, if you don't meet those requirements, it may not install on your computer. And if it does install, you just might have some issues running the software from time to time. So before I actually get into talking about BIM and Revit and the actually working through the program, I just want to give a little bit of a synopsis of why we're talking about building information modeling. What are the major the main concepts within BIM? And when I talk about BIM, I'm also talking about Revit. And when I talk about the model, I'm also talking about BIM. So I use all those words interchangeably as we work. Just so you know, building information modeling is basically is 3D modeling with information that's put into it. And I'll get into more detail here in a minute. But Revit is a form of BIM. It's a software application that runs a BIM platform. There's other BIM software that's out there like ArchiCAD, and Rhino's coming out with a BIM package pretty soon, and so on. So leading up to, just kind of give a little brief, I'm not going to go over all these slides, but just talk about a few things of why we're talking about BIM and the conceptual framework. We have to kind of look back at our architectural process and how we used to, and still do at times, design and also work in our documentation of our particular design to present to not only like in studio for presentations, but also to a contractor. Back in the day, we used to draw everything by hand. Well, you would probably start out with a plan trying to design your particular project. And you might go into section, when you decide you need to start looking at the elevation, you'd go to another piece of paper, start looking at your elevation, or maybe these are all sketches that are all together. And when you start coordinating with other people or start coordinating with your other drawings, you probably had to like overlay everything onto a light table just to see how things were lining up and so on. But the one thing about that is all those items were disconnected. So if you decided to make a change in section, or you decided to make a change in elevation or plan, you ended up having to go back to all of your different pages that you had drawn all your drawings and update those in order to coordinate, so that in the end you had a project that was represented in plan, section, and elevation that was well coordinated throughout. With the introduction of the computer, like CAD systems and so on that everyone's probably familiar with AutoCAD and MicroStation and all these other CAD products, essentially we just took what we were doing in the paper world and put it onto the computer as like a digital drafting board. So while you were still, maybe you were in the digital environment, you were still working in separate files or separate parts of your file. You were drawing a floor plan, then switching to an elevation and then a section. But again, all those items were disconnected. And so if you had to make a change, you had to go back and, through all the different drawings and coordinate those together. Basically what the computer did, it allowed us to erase easier and copy and mirror things quicker. But again, we're disjointed, with our whole entire drawing set. And it also made us where we could, overlay other drawings easier and be able to see what the other disciplines are doing. With the development of software and hardware, as computers got faster and faster, we were able to start seeing 3D computer programs come on board, such as 3D Studio Max, FormZ, and then nowadays SketchUp and Rhino and so on. But basically what that allowed us to do is model our designs in a 3D space, so we could really coordinate and look at every aspect of our design and really understand how it's going to be in virtual space and eventually in the built world. But again, when we had that particular model, we had to somehow still document it. We had to take it back into another system. So we'd have to extract sections and plans from whatever 3D software package we were using and take it back into CAD and then start to develop our drawings. Again, those are disjointed methods so that if we did make a change, nothing updated as we went through. We had to update the model if you wanted the model to be up to date, and then also the drawings and so on. Basically, with building information modeling, all we're really talking about now is that we've got a 3D model that now contains information, and this information can either be information that reports particular data, or it's data that actually drives the design. So these particular models are now parametric. They have parameters that drive the design or start to list particular information for us. And at the same time, it starts to extract all of our plans, sections, and elevations as we're modeling. So we could actually be drawing an elevation, and it would actually be, or drawing a plan, it would actually be developing the model, and vice versa. If we were modeling, it'd be developing these plans and sections. So in the end, this is one unified model in one software application that is going to basically generate your presentation, drawings, your renovations, your particular renderings and so on, and then also your construction documents, so that you can present your project from this one unified particular model. Now, to talk about Revit and to start talking about BIM, it's all about the parameter, and we have to really understand what the parameter is before we can really work within the program. You can actually start working in the program, but you're not going to really understand what all the different components are and why they're acting the way they are unless we understand this one fundamental item. And the parameter, and this is, parameter exists not only in BIM, but it exists in other programs like Grasshopper and scripting and all these other computational programs that you've been using in the college. A parameter is basically just a container of information. It's something that can hold any kind of data. It can be dimensional data. It can be yes, no kind of checkbox. It could be text. It could be anything like a website. It could be anything. But essentially, it's a name that's given to a container that then has a piece of information that either drives the design or starts to report on the design. And what I mean by that is, for instance, in this little slide here, we can make one particular object. And if we make that one object, we can assign parameters to it, and then those parameters will drive this design so that we only have to model this item once and then change a few parameters, and we can have infinite possibilities of this particular item. So it becomes a way of modeling efficiently, but also becomes a way of designing and also a way of producing a more efficient way of working with our components. You can take those particular parametric ideas or the idea of the parameter, and we can get more complex, and we're not going to get into all this, but I just want to show a couple of examples here, is we can actually program a part with parameters so that you see this little part that's off to the left. It has a bunch of parameters that define whether it's going to have a different size aperture or the materials change, depending on where it gets placed on a whole facade system, and there's rules and why that happens. But that one piece, when it repeats across a surface, actually begins to change form and gets to take on different aspects of the parameter and the information, so that we could actually play around with this facade and change the parameters, and we don't have to exhaustively remodel this part over and over again like you would have to do in other programs and so on. Just so we know, we can also take particular models that are actually built, exterior to the program, and if we understand the XYZ coordinate system, we can definitely plot those points into the 3D environment, and also take what you've done, with a hand model and start to put it into a particular program. When you put all those together, I'm just showing some more complex things here, but when you put all those together, you can have basically three parts, and these three parts, because they're driven by parameters, basically can be a form of actually experimenting with and also understanding your design process, or coming up with different solutions without having to exhaustively model over and over again because you've programmed all your parts and pieces. Now, the parameter also works as not only a form of driving the design, but also works at the schematic level, where the parameter can actually report information back to you that's very useful as you're playing around with your design or you're working with your schematic form. You could actually begin to mass intuitively and then extract particular floor levels out of your mass. And as you're modeling and pushing and pulling, Revit will completely report back to you, if you've set up the schedule, exactly what your overall program area is based on those floor plates. So even though you're at kind of a schematic level of design, you're kind of pushing and pulling, you could still have real world data coming back to you that tells you whether or not you're within the particular program requirements of the owner. So it's a good way of looking at those parameters and a way of having those report that information back to you. The parameter goes down to not only the 3D level, but also down to the 2D level. So even eventually in Revit and any program, you're only going to model in 3D to some level of detail. Eventually, you're not going to really be modeling, flashing and bat insulation and all these other things that you'd want to see in a construction detail. But eventually, you'll also have these 2D components that get overlaid on top of the model, and then those get hosted to the model, and so if you were to move a wall, all your detail components also move. But you have these drafted items that add the level of detail to it so that you can have a complete construction document set. But even those 2D components can also be parametric and then can also report data as well. So we can also make one little detail. So I can make this one detail once and then have the parameters that drive it so that I can essentially, depending on the different places I put this particular detail, I can just have it adapt without having to redraw every single time. And lastly, those same 2D details eventually make up the 3D detailing and the tectonics that you would find on your model. So all of this is, even though some of those 2D details were part of a drafting item or a profile, they eventually are also part of your model, so that when you present your model from renderings and also other forms of 3D and also looking at it in sections and so on, all those components show up at the same time and across your drawing set. And this way they're all connected, so that if something moves again, everything is going to move with it. What I would like to do before we actually get into the part of the project environment of Revit, I want to just go through a quick little exercise of what it means to be parametric and how you make something parametric. Because this is very important, because in Revit, we either define for ourselves, we program our own parameters into the program, or Revit already has a set of components that are already pre-programmed. So even though you're drawing a wall sometimes, that wall has embedded within it a set of parameters that you have to constantly change and access. So it's very important that we kind of just start to understand this particular component. What I'm going to do is, for those of you that haven't ever opened up Revit before, obviously if we go down to that start menu down at the left, you can type in your search box just Autodesk. That should bring you to the Autodesk, or I should say Autodesk Revit. Actually, it's not popping up, is it? Revit. There we go. Type. Okay. If you type in Revit, it'll pop up, but basically it'll give you Revit 2014 that you can click on. The other way to find that is you can go just through that, click on all programs, and then if you scroll down to the folder called Autodesk, there is Autodesk Revit, and I've got different programs on my computer, but Revit 2014. And one thing that you have to be very conscious about when you're opening it through this method is there are two parts here. There's Revit 2014 and a Revit Viewer 2014. You want to make sure you open the one called Revit 2014 and doesn't have the viewer in it. If you happen to open up the other one by accident and you start working within that environment, you won't be able to save. So basically the viewer is for if I'm in the office and I want my principal architect who's working with me on the project look at my BIM model, I tell them to open it up in the viewer so they could do whatever they want, but they're not going to be able to mess anything up. Or if they do, it's not going to save. So basically I've had a couple students before do a lot of work and then find out that they couldn't save. So just be real careful with that. When you open up Revit, you'll get to this splash screen that is basically your start screen at all times. And it's basically going to display your top or your last 4 projects that you've been working on, or that it remembers accessing on your hard drive. And there's 2 parts. There's the project environment and there's the family environment. The project environment, this is the main unified model where you will be working. And basically the way Revit works is you eventually bring in certain components. So if you're familiar with SketchUp or Rhino, in SketchUp you have components, in Rhino you have blocks, or in AutoCAD you also have blocks. Those are similar to families, and these are single one-off objects that can be parametric that come into the project environment and you place them in your model. Both of these environments have different ways of working, and we'll get into that. But for now, for this little parametric exercise, I want us to go to Families and click on the icon here called New. And it's going to bring you up this dialog box. And in Revit, everything has to be modeled on a category, especially when we're on a family environment. And I'll get into the categories when we get into the project environment. But essentially, all these categories are tied to specific objects that are part of Revit. So you can see very obvious ones like casework doors. Scroll down, there's windows, planting, and so on and so forth. For now, if we just go to the one here called Profile, so towards kind of the middle bottom, and it's called profile.rft, and just go ahead and hit Open. This is going to be a 2D component that we're going to make that will start to talk about parametric items and how to make a parameter. Now off to the left, you'll notice when you open up Revit, and if you hit Open and you see up the top you have basically up at the top here is your quick access toolbar. Then you have your ribbon toolbar that is up here. You can click on different parts and pieces. Then you've got different tools that are along here. And then off to the left, most of you should have kind of this properties box, and then what's also called the project browser. What I like to do is take this project browser that's down on the bottom, hold in your left mouse button, and slide this all the way to the right and dock it. And that's how we're going to work from now on. So if you open up your Revit and it's the other way, if you can just get it into this format. And the reason for that is when we start working, this project browser starts to grow depending on what we start to do. And the properties box grows into different lengths depending on what tool that we're using. And so if you have everything scrunched together, it starts to make for a lot of scrolling up and down. To dock it, you just try to push it all the way to the right. You may have to reduce it in size a little bit.
Making grasshopper.
Yeah, and then just kind of make it pull off to the right, and eventually it will dock. And if it doesn't dock, it's because it's too long, so just kind of tilt it back or make it smaller. So what I'm going to do here is if we scroll into this crosshairs, this is the origin of this particular family. And all I'm going to do is click on the line command. So if you look at under create, and right up here where it says line, and this is a 2D component, so all we're doing here is starting to get into the idea of parametric design and using parameters. And I just want to take this, when you click on line, you can see here in the draw area, there's this rectangle. If we click on rectangle, I want to draw a rectangle, and it's basically like any other CAD program. You just left click to start, and then right click where you want to end. Now, what we've done here is we made a rectangle. I don't care what size it is, but if you can make it in the top right quadrant, that works pretty well. But this is just basically an object. So if we were to bring this into Revit and start to model this object would always have to be this size. So in SketchUp and other programs, if you decided that you wanted this rectangle a different size, you would have to then make another file. You'd have to do a save as, and then make adjustments to this particular component, and then bring it in as another file, and then place it on your model. But for now, I want to make this so that it's smart, and it has some information that starts to drive it so that we can then manipulate it later. If you click on any line, so notice when I click on that top line of the rectangle, you get this blue dimension. In Revit, everything, when you click on it, is going to end up with a blue dimension. It's called a temporary dimension. That temporary dimension is going to be a place of input. It's a place where you can click on that, whatever your value might be. So I could left click on that. Mine happens to say 7 inches, and I could change that to 1 foot. Or I could change it back to 4 inches and so on. That's the way in Revit we generally work. We're just going to be placing things, and then eventually you move things either by move commands or by these temporary dimensions. I can click on, if I want to move this vertical component, notice then I get a different dimension string that I can then click and then make certain dimensions. So that's the inherent way of working in Revit, in that Revit has an inherent way of making parametric or making components parametric by using those temporary dimensions. But what we can do is click on this component, and you'll notice with the temporary dimensions you get that little icon that looks like a dimension icon. If you click on that, this will make it into a permanent dimension. I'll just drag this off to the side. And I'll do that to the top as well. And I'm basically going to have 2 dimensions here that are 5 inches and 4 inches. You'll have something different. But you should have kind of a vertical and a horizontal.
What if you only see one of them? Like I only see my horizontal or my vertical. I can't seem to get my.
So if you want the vertical, you have to click on one of the horizontal lines, and if you want the horizontal, you have to click on one of the vertical. It sounds
the opposite.
Yeah, it sounds a little backwards, but it kind of makes sense when you see the dimension and how it's being drawn. So while we're here, let's do a save as. This is one thing that's important in Revit, is that up here at the top left where you have got the, it's called the applications menu. It's the big R, is a blue R that's up to the top. You can click on that. And this is where you can open projects and also do your typical saves and also print eventually. So if I do a save as, I'm going to save this as a family. And let's just go ahead and save it somewhere that you can eventually access. And we'll just call this rectangle. In Revit, Revit does not automatically save. So if you're used to other programs where they do an auto save every 15 minutes or something, I think CAD has that set up. Revit doesn't, because your files can eventually get really big, and it doesn't want you to have to wait 10 minutes every 15 minutes for a big file to save. So it gives you intervals that reminds you. But just as a general practice, as you work, when you get things done, you definitely want to come up here and hit the Save button in your Quick Access toolbar. So the last part of this exercise is if we're under the Create tab, you'll see this little icon up here called Family Types. It's up here to the top left, has kind of these blue boxes over it. If we click on that, it'll bring up a dialog box where we can add our information to this particular component. Where it says Parameters, I just want to click on Add. And I'm not going to go over this whole component yet, but if you look here where it says Type of Parameter and click on that, that'll show you all the possible things that a parameter can be. So if you're wondering what a parameter is, it's that container of information, and it can hold any of this particular information. For now, I'm just going to name a parameter. We'll call it H for height, and I'll click Enter. And do another one by clicking Add, and I'll make another one here called D for depth. Now all we've done is made the container. We've made the parameter H and D, and here's the value that it's waiting to hold. And so right now it's at 0. Just click OK and exit out of that. We can now assign these dimensions to that parameter so that we can then eventually parametrically drive this particular component. If we click on the vertical dimension, this green bar that's in the middle, this is called your options bar. As we click on different tools, you'll start to see different options show up in this options bar. So we'll be repeating that over and over again on other commands. Where it says label, we can hit the down arrow and go ahead and assign that vertical dimension to H. And it should now change to H equals whatever. And then we can do the same thing with the horizontal, make that one equal to D. Now we can go ahead and save that, and what we've done is we've made this item that we can now use in the Revit project environment that can actually change as we type in parameters. What that means to be parametric is if I go back to that Family Types dialog box and change these values, so if I type in 6 inches for H and hit apply, notice how my rectangle moves. Type in any other dimensions and hit apply, and as I do that, these dimensions are driving that component. So it's driving that particular design, which means this one component can be modeled one time, and then we can assign it multiple different dimensions and then use it over and over again. So for now, I'm just going to hit save, and we're going to cancel out of that. I just wanted to go through that exercise because it's a very complex concept in a way when you first get introduced to Revit, and people don't introduce this until the end of your basic workshop, and you'll start to notice that everything we do is going to be based on this idea of parametric components and these ideas of changing a parameter. So it's real important that we understand that. Any questions so far? All right, to close out of this, I'm going to hit the applications bar or toolbar here, and we're just going to hit close. Now, if you can go to our, if you can actually go to this website called jrodesign.com/downloads. I'll keep that up there for a second. We're going to download a couple files that I want to work with. One's going to be an image file, and another one's going to be some CAD files that we're going to work with from the very start. So again, it's jrodesign.com/downloads. And you shouldn't need any username or password. It should pop right up. Everyone get there? All right, I'm going to close out of this magnifier. And you're going to want to download, there's a folder here, zip file, called it's called RIC A102.zip file. And what you want to do is right click on that and hit Save Target As, and go ahead and save that somewhere on your desktop or somewhere where you can access it. So we'll download that one. And then you're also going to right click on, at the very top, there's one here called Camden Gallery. There's a page 56 and a page 72 Again, right-click on that and do Save Target As, and save that.
Both of them?
Yes, both of them. I'll magnify that a little bit here. So you should be downloading these two files, the Camden Gallery, page 56 and 72, and then down at the bottom, this one here called Rick A102. Save target as. So if you're using another program, just go ahead and click download. I usually use Internet Explorer when you download files from the internet because it makes it a lot easier. If you're using, I think Google Chrome or Mozilla, it's going to dump it into a downloads folder somewhere on your desktop.
So you said use what instead?
I like to use Internet Explorer. Works a lot easier for the downloads part. I'll let everyone catch up for a second. Okay, so everyone can access the internet? All right, well.
They keep saying retract,
Okay, well, you know what? So it's not that important. I just want to be able to show you a quick little example of how you can start in Revit without having to know all the different parts and pieces. A lot of you have already been working in other programs like, I guess I'm assuming Rhino and SketchUp, or maybe by hand or something like that in your studio so far. So if you're able to access those files, that's great. If not, I wonder why I can get on. Or you guys must be.
Too many of us are trying to do it at the same time.
Yeah, it shouldn't be all right.
I think the people on laptops can get to it.
So I'm on wireless, so maybe that is helping. All right. Well, we'll just kind of move on from there. But when you review this video, if you want, you're welcome to download those particular files. But let's go ahead and open up a project. If we go to the project environment, you should have this little splash screen on your screen here. When you open up a project in Revit, there's different ways of doing it. You can just hit New. When you hit New, a dialog box will pop up, and it wants you to pick a template file. Everything in Revit needs a template file. If you hit the little scroll down menu here, you can pick construction template, architectural, structural, and mechanical. Obviously, we want to be in architectural, but they've also made a quick link shortcut here where you can just click on architectural template. So go ahead and open that up, and you should have this little blank screen here. And you'll notice that there's a lot more information on our toolbar up here at the top, and there's different commands here that look a little bit different from the other file that we were just in. Again, your project browser should be on the right, and then your properties bar is off to the left. One thing I just want to note is before we get into drawing with walls and so on, is that at any moment you can bring in image files as an underlay, and you can also bring in CAD files. So if you happen to have a CAD floor plan, or if you're working in Rhino and extract a section or extract a plan, as long as it is a DWG file, you can bring it into Revit and actually trace on top of it. And Revit will start to recognize the CAD lines and so forth, and be able to react to them as you bring them in. If you have a 3D model and you bring it in from another file format such as Rhino or SketchUp or these other things, you can bring it into Revit, but once it comes into Revit, it is kind of this object. It's this object that you can no longer manipulate. And the reason for that is, coming from other file formats, there's basically no information, no parametric information embedded within it. There's no BIM within those files. So basically Revit treats that as a kind of this dumb object that comes in that you can just view and maybe change some of the materials. But if you want to do any edits, you have to go back into your other program. So pretty much what's advisable is that you could use that as like an underlay or a basis of working in Revit, but eventually you're going to be redrawing that in Revit so that you have a smart object or this BIM component that you can then utilize and utilize all the features of BIM. So what I'm going to do here is I'm going to go to Insert, and this Insert tab, this is where you can bring in all of these components. So for instance, if I had a image file, let's say I made a PDF image of a floor plan that I'm working on, or I had a CAD, or I had a sketch that I was working on, and then I made it into an image file. I can click on that and it'll allow you to bring in whatever particular component that you want. And it's going to look for a bitmap file, JPEG, a PNG, or a TIFF file. So those are your file formats that you have to work with. And I'm going to go ahead and find that file. Let's see, where was I? So I've got, let's say I've got this one particular one called page 72, and I'll bring that in and I'll click open. And bringing in an image file is basically point and click. I just go ahead and click on that, and it will bring in this particular image. Now, when you bring in images, if you're using this as an underlay to sketch and start to work in your Revit environment, one thing we have to do is make sure we scale the image before we work on it, because it's going to scale depending on whatever way it was exported. It might be at an 1/8 scale or a 1/4 inch scale, and we want to be at a full scale when we work. And so typically I like to find something where there's actual dimension line, and if you don't have a dimension line, you want to be able to find an object that you know is supposed to be something like 3 feet. So normally like a door should be 3 feet or something. In Revit, a lot of times if you go to the annotate toolbar up here at the top, annotate is a place where we can draw lines. I call this kind of these construction lines. This is like all your CAD components that you're probably used to in CAD, working in AutoCAD and so on. If I draw this detail line is just going to be this 2D line that's going to be only part of this view, and I'll get into all the views in a little bit. But basically I'm just going to draw a line by pointing and clicking. So I do left, and I'm going to type in as I'm drawing 3 foot 7 inches, and that will draw that line out 3 foot 7 inches. So you can see how this image is not scaled correctly to the Revit environment. So all I have to do is click on this image, and when I click on the image, there's these modify components up here. You'll see all your you can kind of hover over all these different parts and pieces. And one thing I just want to mention is when you're in Revit, if you want to know what a tool does, just hover over it long enough and it will eventually display not only the name of the command, it'll give you in parentheses what the shortcut key is, and it'll give you a little description and then maybe even a little animation showing you what it's doing. You can also hit F1 if you're connected to the internet while you're hovering over it, and it'll take you to the help menu where it'll give you, sometimes it'll give you more information. But I'm going to hover over this particular component here called scale, and I'm going to do in my options toolbar here, you'll notice there's a graphical scale and numerical. I'll keep it on graphical, and I'm going to click on the origin point. Then I'm going to go out to where the drawing says it's 3 foot 7, and then I'm going to bring it back to the real 3 foot 7, and then I'll scale that down. So now I can start drawing on top of this and be able to draw walls and so on. I'm going to keep that open because we're going to draw walls here in a minute and start getting into this environment. The next component here is if we go to insert, I want to be able to insert a CAD file. So there's options to link a CAD file and import. The difference is linking is like an XREF, if you're familiar with XREFs in CAD. If you're not, an XREF is basically you can have other CAD files linked into your main file, and if you change that referenced file, it'll follow all the way through to your final file that it's being displayed in as an XREF, and it'll update. So it's the same thing here. So I can make changes in the linked CAD file, and it'll update in this Revit file if I made any changes. If I import, that's a one-off item. So if I import an object, if I make any changes outside of Revit or outside of this file, it's not going to come back into this particular environment. So I'm just going to, for now, just import this because we don't need to go back and forth. And I'm going to pick that RIC folder, and I'm bringing in this one here called the view number 1, and I'll click on open. It's going to take a minute here because I think this is a pretty big CAD file. But I want to bring this in because it's important that I know you guys are working in these other file formats, that you can have a quick way of coming into Revit and sort of working. So here's this CAD file. It's got a lot of information on it, but it's basically a second floor plan of a project. But you can see that I've got walls and doors and so on, and I can start to use that as an underlay to trace on top of. Now, everyone, even if you don't have these images or these CAD files, you can do these next steps, and we can, this is the last I'll show of these particular files. But for right now, if everyone can click on at the very top here, at the quick access toolbar, there's this command up here called thin lines. And the reason I'm clicking on that is Revit likes to show you line weights as you draw, and sometimes as you zoom in they get really thick and it's hard to see what you're really doing. And if you turn on the thin lines, it makes everything, all the line weights go away to 0 just for this view, and makes it so we can zoom in on things a lot quicker. I'm going to take a measurement. There's a little measure tool here. I'm just going to measure what this wall happens to be, which is 4 7/8. So it's close to 5 inches. That's fine. Let's go ahead and draw some walls. Here's under the Architecture tab, you'll notice all these different commands here, and we're going to concentrate on this one here called Walls for the very basic start. Now, a lot of people have mentioned, and I've heard, that you can't really work in Revit until you know a lot of information, about what your wall is going to be made out of, what your doors are going to look like, all these different parts and pieces. The one big thing is, everyone wants to know, well, in Revit you have to enter in all this information about what the different layers are of your wall component. We can actually start at a very schematic level, at a very generic level of just knowing, when you draw in CAD, you're going to draw a wall that's maybe 6 inches wide or 1 foot wide or 4 inches wide or whatever. You're going to draw something of a particular thickness. So when you click on wall, you'll notice in the properties bar, this changes, shows you some parameters. So this properties bar is always going to show you particular parameters that are assigned to this particular walls. If we click on this part where it says basic wall generic 8 inches, you get this pull down menu of different wall options that basically come with Revit. Now, the way Revit works is it always starts with a component. So in every menu there's going to be at least one item, and then it expects you to eventually add your own or duplicate and edit your own components from time to time. So just because you don't see something in here doesn't mean it doesn't exist. It just means you have to make it eventually. But you'll see that there's these other components here. There's one here called generic 5 inch. I'm going to go ahead and click on that, and then we can start drawing. You notice when we click on generic 5 inch, off to the top middle, you'll see our different draw commands, just like we had when we were drawing those lines in that other file. So I can just draw a line, and if I draw a line, I'm going to hover over and just kind of point and click, and all I'm doing is drawing, kind of tracing on top of this. Now it's a little bit hard to see with the CAD file, but if I turn on my line weights, there's my line or my wall that I just drew. That's going to be 5 inches thick. So basically, when we're drawing walls, it's drawing the two outer lines and showing the space in between. Now, because this is a CAD file underneath, I'm going to delete that by selecting it and then hitting the delete key on my keyboard. I can click on wall, and there's this other option here called pick lines. So if I have CAD lines underneath, I can actually pick the CAD lines underneath, and it'll automatically draw a line all the way based on whatever the length of that CAD line happened to be. So if you happen to have a lot of CAD stuff already drawn, you could start, just clicking and clicking all your different lines, and all of a sudden you've got most of your floor plan all the way inputted into Revit. So I'm not going to go too much further into the CAD underlay, but just know you have that as an option. I'm going to delete that for now by clicking on it, hitting delete. I'm going to click on that wall, hit delete. Oops. And again, I could have done the same thing with the image, but the only thing that's different is I can't pick the pick lines command because there is no vector lines that are underneath that Revit can recognize. So we can basically just trace on top of our image if you wanted to. I'm also going to delete that by selecting it and hitting delete. All right, so I want to orient you a little bit to the Revit interface and kind of maneuvering in Revit, and we're going to draw some walls and get into going from a simple wall to a little more complex walls and placing doors and windows. First thing you need to know is that Revit, when you start up, you've got in your project browser, you have level 1 and level 2. You've got some elevations, and you've got some other information here in this project browser. That's your menu. If I click on an elevation, so let's go ahead and click on the north elevation. You double left click on it. That brings you into the elevation view. And what that is basically showing you an elevation view of this model space, this model environment. If we zoom in on those little datums, there are 2 datums that are set here. One's at 0 and one's called level 1. One's called level 2. If you look at your project browser, you can also see level 1 and level 2 sitting there. These are direct links to your floor plan. So these datums are basically cut lines representing the first floor and the second floor. I can move these, so typically you're probably not going to have a 10-foot floor-to-floor height. If I click on that number where it says 10 foot, I could change this to 14 feet, and that'll move up. And because it moved up to the 14-foot mark, everything is going to move up with it. I could also click on that datum, that top one, and if you kind of zoom out a little bit and zoom to the left, you see those temporary dimensions pop up again. And I could click on that, type in 15 feet, and that will update. And you'll notice when we go back, it also updated our number over here. So everything is going to be connected here in Revit. One thing to keep in mind is anytime you see anything that is in blue, it's hard to see on the screen the difference here, but this one is in blue, and if I double left click on the blue target, somewhere in the middle, it actually took me into the level 2 floor plan. You'll start to see that more and more when we do sections and elevations. When you double click on things, it'll take you into different parts of your model. If you go back to the north elevation, another thing I want you to be aware of is if you click on one of these things, and let's say you don't want that to show up in your drawing, and you hit delete on your keyboard, you're actually deleting a model view or another drawing that's part of your model. So be very careful what you delete and pay attention to this warning sign, because a lot of times you might, in order to model, you'll have a lot of different section marks everywhere or elevations, and then when you go to print for Studio, you don't want those to show up, so you're going to delete them all, and then basically you're going to lose a lot of work that happened to be in other drawings. So we'll get into visibility later, but you can turn those things on and off and hide them, but just be aware of what you delete when you're in these BIM environments. So let's go back to the level 1 floor plan, and I'm going to zoom in a little bit, and if you are kind of zoomed out somewhere else, if you type in ZF on your keyboard, it doesn't have to be together at the same time, but the Z and then F, that'll be zoom fit, and it should bring you to this particular environment or this overall view. You see all these arrows pointing towards the center? That's where we're going to model basically from that in that area. Just go ahead and draw some more walls. So if you click on the wall, let's go ahead and draw a rectangle, and I'm just going to keep it at generic 5-inch for now. And let's just draw, and for now I'm just going to point and click. I don't really care what the dimensions are. A lot of times in Revit it's just best to sometimes just draw and then get the dimensions the way you want them. Just like here's our rectangle, just like in that last file that we were just in, I can click on this element, and I'm going to change this to be, let's say, 40 feet. Then I'm going to take the top component, horizontal one, and click on it, and we can click on our dimension here, and let's make that, let's just say 10 feet. So now we've got this kind of block that is 40 feet by 10 feet wide. But notice when we were dimensioning that,
What did you use to create the rectangle?
I just used clicking on architecture, wall, generic 5 inches, and then there's this option here in the draw command for the rectangle. And I just did a point and then point.
Thank you.
Yep. Now you'll notice when I zoom in a little bit here so we could read those dimensions, if we click on that dimension string, notice how it's going to the center of those walls. We've got 10-foot center to center, and if I look at the other one, it's going 40-foot center to center. Well, if we're trying to draw, if I know I'm trying to do like an office block, for instance, and I know I want all my offices to be 10 feet interior, one thing we can do is if you click on these blue temporary dimensions, you notice they've got these dots on the top and bottom here. If I click on that dot, it'll change where that's being referenced from. And so I can click on them until they rotate so they're both in the middle. And then that's really where I want my 10-foot dimension to be. When I click on that again, it'll remember where we left off last time. And so it'll be able to, you'll be able to enter that input again. I'm going to do the same thing with this 40-foot. Just cycle through and make sure that this is 40 foot from interior to interior. Now this other part is I know I want basically 4 offices within here, so I'm going to draw 3 more walls. I'm going to draw the same type of walls, the 5 inches. And again, I don't care where I put them, but I'm going to make them go from one wall to the other. Again, it doesn't matter where they are in this office block. Notice what happens when we draw. As soon as it connects to another wall, it automatically trims that intersection. So if you're used to CAD and you're having to draw your walls, you have to split your line here, and then you have to trim and extend and clean that up. Revit will automatically join things for you so that they start to show up right. So one last thing is, before we get into some more of these settings, while we're in this generic 5-inch wall type, if you click on this part in the properties box where it says edit type, this will bring up this dialog box that's all about this particular wall environment. And again, these are more parameters that we can enter in that make up this particular component. For now, I'm going to enter in some parameters that have to do with the graphics of how these walls look at a particular level of detail. Notice right here where it says coarse scale fill pattern. If you click in that white space, this is going to be very apparent, or it's going to happen a lot when we work in Revit. You click on a piece of white space, and this little gray button will pop up. When we click on that, this brings us to a dialog box for some more input. I'm just going to scroll down till I can find solid fill, and then click OK, and we'll keep it at that. If I exit out or click OK, notice all my walls turned black and are now in this like filled in pattern, kind of like you would see on a presentation floor plan, when you're printing for your schematic level design, review or something like that. All of your wall types, as long as you put in this coarse fill pattern, will turn this particular color or whatever color you put in there, and we had it set to black, as long as down here at the bottom of your view, notice where it says 1/8 inch equals a foot, there's this little rectangle down here called detail level coarse. If I click on that, I can change this to coarse, medium, and fine, and when I get out of the coarse view, it goes back to more of a black and white type of pattern. So those are starting to get into a little bit of level of detail that we'll start to see in other wall types here shortly. But one thing that we can do with drawing in Revit is we've used the temporary dimensions. Another component to Revit, and especially modeling, is that under Annotate, we can use actual dimensions that you would place that you would typically see on a piece of paper. We can actually use those to also set constraints and set particular equality constraints or locked constraints to our design. So when we use these particular dimensions, if we're in the Annotate tab and then Align Dimensions, I'm going to click on that, and then I'm going to dimension. Notice how when I hover over kind of the center of the wall, the little dashed line pops up. I'm going to click on that, and then I'm going to click on all the center lines of all of these other walls, and we'll just keep doing that until we get to the end. Once you get to the end, if you just drag this off to the bottom and then click somewhere off into space, and that'll make it a kind of this permanent dimension. So what this does is basically you'll notice when we click on that dimension, you see padlocks. You also see this thing here called EQ. So you've got what these are called equality, or make everything equal, equality settings. With dimensions, we can lock components together, and we can also make things equal so that they parametrically react to one another as we design. So right now, if we click equal, it'll make our office block where all these walls are now equal. So instead of having to do the math like you would normally do in CAD, I'd have to calculate, obviously 40 feet, divide by 4, that's easy. But, we'd have to calculate, what all of our center line to center line dimensions are in order to do our offsets and do all that kind of thing. We can just use these dimensions to then make these particular equality settings set. What's nice about that is if you're still playing around with your design or your floor plan, if you know that this particular part of your design needs to always be equal, 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 you can keep those equality settings set. And if I were to click on one of these walls, and let's say I later decide, these really needed to be 42 feet, or let's say 45 feet apart. As soon as I do that, because they're all set to an equality setting, they parametrically move, and you've got equal, equal, equal offices as you stretch and pull things back and forth. Another component to that is you can also lock components to there. So let's say we have doors. We need some way of getting into these offices. And again, right now we're just drawing in 2D. We haven't really looked at this in 3D yet, but we are making a model as we're drawing here. If we go to architecture and click on door, I'm just going to use whatever the first door is that pops up because I don't want to get into that too much right now. But again, you'll see there's different dimensions for this one door type. And we can go ahead and place this door, and you'll notice we can't place it until we hover over a wall. You'll get this little no symbol as you're anywhere else. There's a lot of components that are out there that need a host. So doors and windows always need to be within a wall. There's other components that need to get hosted. There's wall-hosted components that we'll get into later, but lights sometimes need to be hosted to ceilings. So just so you know, if you're trying to place something and you see this no symbol, it's probably because you don't have an appropriate host in order for it to be placed. So let's just hover over a wall here, and I'm going to start to place this door. Before I place it, if I hit the space bar, that will rotate the component, and if I kind of move up on the wall, it'll switch over to the other side. And if I place the door, I also get these different flip handles that I can go ahead and flip them into the right direction that I need it to be. Notice as I place the door, it automatically trimmed out everything for us, so another quick, nice little feature. But let's say that I know that all of my offices need to be equal, equal, but eventually I also want my doors to always be a certain distance from this wall. We want to be able to set up what's called a constraint, and we can do that with these dimensions. So let's just say, let's make a dimension here from the inside of this wall. Notice I can't select the inside of the wall. A lot of times in Revit, while you're working, you have to hit the tab key. And when you press the tab key, don't hold it in, but press it. It'll cycle through different options for you to select. I'm going to tab over until I can select that inner wall. And then I'm going to select the kind of the inside face of that door. So I have, in my case, 9.5 inches. I'm going to select the door, and then I can pick that dimension, and we can type in 3 inches. I'm going to say that this door has to always be, 3 inches minimum from that wall, for instance. If I click that dimension, notice because it was only one dimension, we don't have the opportunity to do equality settings, but there's the little padlock that shows up. If I click on the padlock, that will lock that dimension. Just as an example, if we make another door, let's make it into this other office. And this time we won't lock it. We'll just kind of place it where it looks right, looks kind of close over there. So the door on the left is locked. The door on the right is just kind of floating there. It doesn't have any kind of constraints. If I were to go back to these equality settings, and I click on this vertical wall that's off to the right, and I change this back to 40 feet, notice that my door over here moved with it, and it moved back to, so wherever that wall moved to, it's always 3 inches off. Notice over here, that door stayed where it was placed, but now the wall's, moving where it's conflicting with it. So we just want to be able to, at times, there's times where you want to lock things and constrain things together, and that's kind of number one, it's a quick way of working, especially with the equality settings, and at the same time, it's an efficient way of working where we don't have to move all of our objects. If we're still playing around with the overall, size of our building, we don't have to go every time we make that 40-foot change or 50-foot change. We don't have to go back and individually change every single door, to be the right dimension or so on. So it saves you a little bit of time. So I'm going to go ahead and place. I'm just going to place more of these doors. I'm going to hit the. I deleted that one that wasn't set, and I'm going to take this other one and I'm going to hit copy. So if I make a selection first, you always make a selection to the item that you're going to manipulate. And there's this little copy command here at the top. And I'm going to copy from the inside corner. And I'm just going to copy this door over and over. Notice I can't copy over and over again. And that's because when I hit the copy command, notice in the options toolbar, there's this little icon here or checkbox where it says multiple. If I make that check, that means I can actually go ahead and copy this over and over again as I manipulate and move down here. So I've now got this office block and these walls and so on. We haven't really paid attention to the parameters that are making this 3 dimensions. You also notice we don't have a 3D view here, which I always find odd that the main template when you come into BIM doesn't have a 3D view, since this is going to be a 3D model. But since we don't have a 3D model, if we go to View and click on 3D View, that will bring up a 3D view, and it'll also add it into our project browser, and then also our little 3D, you'll see our 3D view off to the side here. Just for so that shows up better on the screen, down here at the bottom where it says Visual Style, I'm going to change that by clicking on that to a shaded view. So some things about maneuvering in 3D. I can zoom in, and this is in any view actually. If I use my mouse wheel, I can zoom in by going towards the screen, zoom out by scrolling back, kind of like in every program. Hold in the mouse button, and then you can pan around. But if you're in 3D, if you hold in the Shift key and the right mouse button, you can now orbit around your model. You also notice there's this view cube up to the right. I can click on different parts of the view cube, and it'll rotate my model around. So you can see this is, basically we've started making a model, very elementary model, but it's based off of that floor plan that we were working with. Somehow these walls knew to extrude to a certain height. They've gone a certain height, and then our doors were also made, to a particular height and width and so on. If you click on a wall, notice off to the left, each wall, as you draw a wall, even though we were drawing in plan view, has a set of 3D components that are associated with it. So there's a base constraint, it's set to level 1. There's a base offset. There's a top constraint, top offset, and then some other information here. It even tell you, area and volume and things that we don't really need to know right now. But essentially, these parameters that are embedded within this wall define its other direction, its 3D dimension, kind of moving in the z-axis. I'm going to pick this wall that's up here where actually I'll pick the one that's kind of facing here on the bottom. Now the way this works is, since we were drawing on the level 1 floor plan, it automatically knows that you wanted your walls to be on level 1. So that's why the base constraint is set to level 1. We could set this to level 2 if we wanted to. So if I click on level 1 and click on level 2 and change my top constraint, let's say to unconnected, and none of those things are going to change until I move my mouse cursor out into the model space, and then that kind of updates. The reason for that is so you can make all your manipulations, and then eventually it'll update it in the model as you enter the model space again. But you'll notice that this wall now moved up to some particular height, but now its base constraint is on level 2. We could also make this go back to level 1, so I'll click on it, go to level 1, and I'll change my base offset to maybe 5 feet, and click OK, and it's moved up. What that's saying is this wall now exists starting 5 feet above wherever level 1 datum happened to be. Remember those datums in elevation? That's your line of reference for level 1 and level 2. Now, what's important about these constraints is that typically when you start drawing by default, and I'll change this back to 0, by default your walls are going to be unconnected. Sometimes they might get connected to a datum or so on, but typically all these walls might end up being unconnected with some particular height. You could have a top constraint actually set to another datum. So if I click on that and make it set to level 2, and I think all of my walls were set to level 2. And what's important about that is if they're set to level 2, that particular datum, that's the constraint. If I go back into an elevation view, and again, if we're in our design phase and we're still trying to play with how high our floor-to-floor heights are going to be and all these other things, or later on in design you decide that you have to grow your building a little bit or shrink it, as long as you've got these particular settings or these constraints, I can come back here to level 2 and click on this and type in 14 feet. And notice what happens is all of my walls move down with it. So I could play around with this as much as I want, and my whole entire model is going to constantly update and change as we model. So again, we don't have to go around and change all of our walls because throughout the whole entire project we had to make that update. Here we are in elevation. I'm looking at a north elevation, and if you drew the doors on the north side like I was doing, you should see your doors in elevation view. And let's say I pick one of these doors in elevation, and let's go ahead and move it. So I'll just click on the move command, and I'm going to move this over like 1 foot. So I moved this in elevation, but now if you go back to level 1 floor plan, you should also see that this door moved, and again in 3D, that door should have moved as well. So when you're looking in any view, whether it's even though it's an elevation view or a plan view, or even in 3D, if you move something, so again I can be in 3D and move that, that's going to update in all the other views. So even though we've got these different views of the model that seem like they're different 2D representations and 3D representations, they're all connected to the model. They're all part of the BIM model, and so that's all part of this particular one unified component. So just be aware as you move things, and if you don't like something in one view, that's going to change and update everywhere when you make that change. Let's go ahead and hit save for now. It doesn't really matter what this is called. By default, it's at project 1, which sounds about right for now. Another thing I want to represent before we get into more about the wall is, let's take this middle wall, for instance, select it, and change the base offset to 5 feet. Now I'm in the plan view, and notice that it just disappeared because of something. But if I look at it in 3D, my wall is still there, and it even is still connected to the level 2 datum, but it somehow disappeared out of my floor plan.
It's because when you cut.
Right, so every datum that you see, so if you've got level 1 datum, level 2 datum, and so on, has a cut plane that's associated with it. So if I were to look at level 1, if I click on level 1 over here in the project browser, even the views have parameters that are assigned to it. You'll see these properties off to the left, and if you scroll down, you should see this component here called view range, and then the button here called edit. That's because by default your cut level is set to 4 feet. So for some reason, if you're doing something and you want to, you've got things up higher than 4 feet, you're not going to see them in this cut level. If for some reason you've got windows that are up 5 feet high or so on, and you want them to actually show up in your plan, you may have to change your cut level here by changing this to, let's say, 5 foot 6 inches. And everyone knows that the foot symbol is the apostrophe, and the inch symbol is the quotation mark. So whenever I type in 5 foot 6 inches, that's what I'm typing. So I've got 5 foot 6 inches, and now when I click OK, you see that wall comes back and starts to show that information. So if you don't see things, that's probably one reason. You just have to play around with that view range a little bit.
Can you tell it to show overhead lines?
We can trace overhead lines and basically have it connected to the model, then it'll update. But it won't show the overhead stuff necessarily from this view. All right, so let's go ahead and get into a little bit more detail about the walls. There's other different types of walls, and I also want to start talking about windows and curtain wall systems because those are a little more interesting. We'll keep this office block down here at the bottom, so maybe we'll eventually have something to work with. Draw that door back. So I'm going to move off to the left here a little bit. And if we go back to architecture and look at the wall, let's go ahead and draw a different type of wall. And so right now, those are the generic walls. Those generic walls are basically where you would probably start out in schematic design. You could pick any of the ones that are here, the 5-inch, 6-inch, 12-inch, and so on. I guess one thing I should note is if you want to change that dimension, that this is a 5-inch thick wall, go ahead and click on that and click Edit Type. And anytime you want to make a change, and let's say you don't see, you want this wall to happen to be, let's say 9 inches thick, you don't see that in that drop-down menu. So we can update this by duplicating, and I'm going to call this generic 9-inch for now. And all we have to do is go into where it says Edit Structure, and there's a little value there called 5 inches that's already set. We can change that to 9 inches and click OK, and that'll make that a 9-inch wall. So if you're at the schematic level, you can just go ahead and play around with those dimensions. And make sure that you always hit duplicate so that you don't change all the other different values of the other wall type. You notice that these are all called generic 5 inches, and if we would have just updated that one to 9 inches, all of those would update. So go ahead back to the wall command, and we're going to draw another wall type here called, let's do exterior brick on CMU. We can just go ahead and draw, I'll kind of draw off to the left here. You notice as I'm drawing, it's always centered. So I'm always centered, my wall's always being offset from the center line that I'm drawing. That's because our location line is set to wall center line up here in the options bar. Before I draw, if I go back to that wall command, I can set that to be finish face exterior or any of these other ones interior. If I do finish face exterior and I start drawing, you notice how I've got this particular wall kind of offset from that exterior line. What is that beeping noise? All right, here, as we're drawing, if we hit the space bar, that'll flip the wall. Not so important, but if you have a bunch of different layers that make up this wall type, and you'll notice that this is where we've got a lot of different layers, a lot more information that's part of this wall. We've got the brick, we've got airspace, rigid insulation, CMU, a furring stud, and then a 5/8" chipboard. That's all part of this wall type. If we click on this and click Edit Type and look at the structure of this wall, you notice that the generic wall had 5 inches of thickness, and this one has 1 foot 7.5 inches of thickness, but it's made up of all these different layers and these different components. This is what's called a compound wall in Revit, and essentially these are things that you would have to know more about your wall type, and you would eventually develop your wall later on in the semester. Now I think I'll get a little bit more in detail later on in the workshops about that, but just so you know, if you're drawing with these other wall types, you're going to have a lot more information that's already embedded in there that comes default with Revit. What I would recommend is at the schematic level of design, you're drawing with your generic wall, and eventually we can come back to your generic wall. So if I went back to my 5-inch wall, I can click on Edit Type, and as our design develops, I can add, so I'll just hit insert here just as an example and move this one component up. I could add another layer here of something, and I'm not going to get into what it is, but I could type in that this other layer is 3 inches, and then this wall type grows with that other layer part of it. So that's what I mean by you can start in a schematic level of design right away. You don't have to know all that information about your wall type, which a lot of people don't know what your wall is going to be until you're further along in design. And so if you start off with knowing that at least I'm going to be something like 8 inches or a foot wide, I can eventually fill in the details as I go in later on in the semester.
So actually, I would echo that completely in that there are a lot of default wall types in Revit. But as an architect, you're responsible for knowing what the construction assembly is to meet local codes for, I don't know, insulation or fireproofing, etc. So while those are handy for sketching, I think in this studio and probably in general, following that logic is super important. Start with a default wall type, and then as you start moving through your project, you can edit the assembly layers based on what you know in terms of code and what the requirements are as you build them, right? Don't rely on the software to produce the wall assembly that's required for your structure. Okay.
And that's also real important in representing your project in the, especially when you get into the rendering phase, because again, in the rendering phase, you're going to eventually know, that's where you start to assign your materials and you start to understand like what your walls are going to be made out of. And that's when you start to get into a little bit of that level of detail where you add in the layer on the outside is going to be brick versus some other component and so on. So that's all part of the visualization stage, and then also your development as you go through your project towards the end. So I'm going to not hit on the compound wall idea so much, but what I want to do is talk about stacked walls. You can actually have, so you can see right now we've drawn just that one wall type, but we can actually stack walls on top of one another. So as long as you have a wall type made, so let's say I go back to my walls over here under architecture, and I've got a 5-inch wall that we've been working with, and luckily we've already got a generic 12-inch wall. Let's say we want to have down at the bottom of our project, our wall is going to be thicker, and then later on as it gets higher and higher, it becomes thinner, to like a different dimension. There's ways of making a wall type that can actually stack on top of one another, and then there's a few tricks on how to work with that. I'm going to delete this one that's off to the top here. So what we can do is under wall, architecture wall, and if we scroll down here to the very bottom, there's this wall type down here called exterior stacked wall. Actually, it's just stacked wall. And it has one component there already. It's called exterior brick over CMU with metal stud. As I said, Revit always starts with something. It tries to show you like an example of what you can do with that command, and then it's up to you to edit and make it more customized for what you're doing. So if I click on that, this is where we're going to edit this to something that's a little more generic for right now. So if we click on edit type, we get this dialog box that pops up, and it has just the structure of this wall type. I'm going to duplicate this because we want to make our own wall type. And let's call this generic 12-inch and 5-inch, just for now. I like to name things the obvious, what it is that we're actually using, so that when I'm placing it, especially when you get more and more components, I know what I'm selecting. So when I click on edit edit the structure, we basically get to assign over here in the dialog box, we get to assign what walls we're going to stack on top of one another and what their parameters are that are assigned to them. So right here where it says exterior CMU on metal stud here at the bottom, let's change that to generic 12-inch. And our one that's on the top we can change to generic 5-inch. Now these walls, we can look at it in a preview. So if I click on this little preview button, it'll show us a preview of the stacked wall assembly. So you can see how I've got the 12-inch and it's stacked on top of this other one. And the 12-inch only goes up a certain height. And that's because there's a parameter set at the bottom here where it says 3 foot. I could change that to 5 feet. Click off into another space that'll update. A stacked wall always has one constant and one variable. And we can stack as many wall types as we want. We could have 3 or 4 different walls on top of one another. And this is a good way of, also getting some detail in your model or your wall assembly. But essentially, because your walls, remember, are parametric by default, remember they have base constraints and top constraints and can stretch depending on where they're placed in the model, one component of it always has to be variable. So we either have to decide if you want the top to always be consistent or the bottom to be always consistent or the middle. So for now, we'll just keep it out at 5 feet and then let the top be variable. If you wanted to change that, if you click on the bottom portion, the little button here, down here at the bottom allows you to change which is variable. Also, you'll notice that the stacking is right there at the center line. And necessarily, that might not necessarily be how you want those walls to stack. And so Revit allows you to manipulate this a little bit, so you can change the offset at the top where you can align it to the exterior, or I could align it so that the interior aligns, and then I can go from there, or go back to the middle. If you decide that it's not still at the right location, maybe it should only be like 1 inches offset from the exterior, Revit gives you, so you can do the finished face exterior, and then you've got other parameters off here to the right where you could change the offset. So I could change this to 1 inch. And sometimes you have to play around with whether or not it's a positive 1 inch, so that's why the preview is good. Or it looks like I want it to go in, so I want to do a negative 1 inch. And then it will come in. So anyway, I can control that all I want and kind of manipulate those and move them around. But when I go ahead and click OK, and OK again, I can now start drawing with this, and I'll draw off to the right. Let's go ahead and draw kind of this L shape. And I'm drawing with my default wall that, yeah, that's the 12 inch by 5 inch, okay. So now when I look at this in 3D, you can see the little stacked component and a little bit of detail in there that's assigned to it. If this wall, because remember we have the top portion is variable, we can change that. Let's say we change that height of that wall to 30 feet. Notice how the base stays where it is, and then the top is extends to whatever variable might occur. Another component that's part of the stacked wall assembly, if you start to kind of get in a little bit of detail with your modeling there, is when you start to place doors and windows and so forth into that wall. Let's just go ahead and look at this in floor plan again. And I'll place a door kind of on this one face right there. Now when I look at that in 3D, you notice that the door, in this case, in my case, went all the way through to the back side and also cut through that part that was protruding. You could change that, which you probably wouldn't want to do in this case because it actually did it correctly. But in some cases, it might think that the main wall is that one that's out in the further face. And so sometimes you have to tell Revit what you want, where the host should be. And so when I click on that particular object, you can see here where it says pick primary host. I can pick that and then select the outside, and that'll move that door over to that outside component. So obviously I'd only do that if it happened to be placed on the outside and I really wanted it to go all the way through. Let's talk a little bit about windows and also about curtain wall systems, because all of these are a part of the wall assembly and working with different ways of modeling in that wall components or with the wall components. Windows work exactly the same as the doors. We basically go back here to the architecture command and we can click on window, and you basically again come with one window type, and then we can go ahead and place it. So I'm not going to go over that too much, except that basically when we place that window, it has a default sill height. So right now this one happens to be at 1 foot. So when I look at that, that means that window is being placed at 1 foot. If I were to change that sill height to 3 feet, that moves that up. So if you don't like the window that comes with Revit, one thing is that you can do is you can actually load in a new window that's default. But I highly encourage that everything in Revit isn't about the default component. It's about your own custom component. And we're going to get into another workshop later where we talk about making some of those custom components and getting into more detail about these. But for Windows, I would actually suggest using the curtain wall system because you got a lot more freedom and actually be able to make your design customized to what you're doing for your particular project. Because basically these windows, if we were to load them in, if I click on Insert and Load Family, this is all the stuff that comes with Revit, you'll notice that we don't really get a whole lot of nice architectural options as you kind of scroll through there. They're very residential and kind of basic cookie cutter type of stuff. So a lot of times I would not ever recommend bringing these in, but sometimes they are a placeholder for another time. What I would recommend is actually using this curtain wall assembly because the window, again, is just going to be what you have there, or if you actually know a little more advanced modeling skills, you can make your own custom family component. So the curtain wall assembly works we can go back into level 1 by going ahead and clicking on architecture, and we can click on the down arrow, not down arrow, but just wall. And under this menu, as we scroll down towards the bottom, you notice you have these wall types here that look like glass, and they're called curtain wall, exterior glazing, and storefront. Let's go ahead and just click on curtain wall number 1. I'm going to draw kind of between my L and this office component. Let's see if I actually have something there. Okay. So again, the curtain wall, even though we're drawing a window, these are being drawn as a wall component because they're basically a wall of glass that we're eventually going to divide up and use mullions and other details to define it as a window type. We can basically draw with a curtain wall, and there's also a storefront assembly, and we'll go over kind of the difference of those two. Going over the curtain wall number 1, let's just go ahead and draw. I'm going to draw between two objects here. You can draw wherever you want on your screen. You notice I'm basically, if we look at the zoom in here, I basically just drawn a piece of glass. If I hit the space bar when I select it, obviously we'll flip it from one piece to the other. And again, I just have this little piece of glass that gets drawn in there. If I look at it in 3D, it's just like a wall assembly. If I click on it, it has a base offset and a top constraint, and then it has some other details that will be associated with the divided glass. In order to work with a curtain wall assembly and to make this more customized to what you are doing and what's part of your design, we have to work on it either in 3D or actually in elevation. So it's actually a lot easier to work in elevation. So if I look at my floor plan, I'm going to zoom out. You see these little triangles going all the way around your model? Those are your elevation views. Now I'm going to pick the one that's staring and looking right at that particular face. So that would be my elevation down here. I can double left click on it, which is obviously the south elevation also down here at the bottom. Now one thing I like to do, because in the hidden line mode everything is black and white, I like to differentiate what my glass type is and versus what's just kind of a wall component, so I can start to see which is which. If we go to Manage and click on Materials, I'm going to type in the little search box at the top, capital G and then LASS, type in glass. I'm going to find the material here called glass. And you'll notice that there's there's a surface pattern and a cut pattern. Every wall has a material that can eventually be applied to it. And the surface pattern is what you see whenever you're looking at it in section or if you're looking at it in elevation. So it can be some kind of hatch pattern that represents brick. It could be a hatch pattern that represents CMU or stone or just a solid color. Your cut pattern is whatever you want it to look like when you cut it in section or plan. So let's say when you cut your wall, you wanted the cross hatch pattern. That's where you would eventually set this in this material box. And we'll get into those later. But what I want to do right now is surface pattern. I want to change the pattern by clicking on where it says none. I'm going to scroll down and find solid fill, click OK. Then I'm going to change this RGB value 000 and click on this kind of light gray color and click OK. It's not really important that you do all those steps, but I like to, again, kind of differentiate a little bit in my drawing what is kind of glass and what is these other materials. Also helps show up on the screen a little bit better up here. So now while you're looking at this in elevation, what we can do is start to customize how this gets divided up and look in order for this to be our window wall. When we click on the architectural tab, you'll notice off to the kind of the top middle left, there's this option here called curtain grid. Click on that and hover over your horizontal assembly or your horizontal line boundary of that glass, or if you hover over the vertical, you'll start to see that dashed line show up. Those are basically the grid that where you can start to divide your glass. So I'm just going to go ahead and place a couple here. I'm not really paying attention to where I'm placing them. I'll do the same down here, just like that. Now those equality settings and everything we just did with the wall, they apply with in this environment as well. I can go ahead and click on dimensions, and I'm going to dimension to all of these and make sure they're equal if I wanted to, which I don't normally ever like to do, but you could make those all equal. And then I could also make this where this top piece, let's change that to something like 7, or let's do 8 foot 1 inches. And then I'll make this other one where it's equal between the top of the wall and that other horizontal piece that I just created. So anyway, what we're doing here is we're just dividing up the glass of how you would like to see your particular window design. And we could also, delete them, whatever you want to do. Anyway, so once you've done your divisions and how you want those divided, we can go ahead and click on mullion. And then we can either add mullions at each grid line individually. So I could click on these. Or I could click on by one segment at a time. So I could kind of design that I only want the mullions in the middle. Or I could just click on all grid lines, and that will apply a mullion type all over this particular glass. So now when I look at this in 3D, I actually have a window that represents something like you would normally see when you're working on a model. If you want to customize the size of those mullions, you can click on each of those mullions, and notice right here it's referencing a rectangular mullion, 2.5 inches by 5 inch rectangular. You could click on Edit Type. We can hit Duplicate. And let's say I'm going to do 2 inch by 6 inch as the name. And then again, we've got parameters here to define how we make this change or this particular object change. So I can look at the dimensions here. There's a width on side 2 and side 1, and there's also a thickness. The thickness, which should actually be the depth in reality, is the 6 inches. And then the way that Revit places the mullion, it's always placed on the center line of the grid line that you work on. So, except when you get to the edges, it knows to place it all, on the interior. So basically, you're cutting your dimension in half. So I want 2 inches on one side, 1 inch on one side, and 1 inch on the other. That'll make it where this particular mullion now changed to that other dimension. Can't really see it too well up there because I wasn't very drastic, but it did make it a little bit different. Now this particular curtain wall assembly, there's a couple things we have to know about it, is that we can make it its own wall component, so that's what I've done here. We can also make it where it's embedded within another wall type, so it actually looks like a particular window. I'm going to kind of zoom in over here where I haven't drawn any windows. And I'm going to click on Wall and go back to Curtain Wall 1. And this time I'm going to make my Level 1 constraint. Let's make the base offset up at, let's say, 2 feet. and we'll do the unconnected height. Let's just make it like 4 feet for now. Now I'm going to draw right here at the center line of this particular wall. I'm just going to draw my glass, and I'm going to hit the space bar because I want the glass towards the outside. And notice I get this little warning down here at the bottom right saying I have overlapping walls. That's because right now, as a default, this particular curtain wall isn't set to cut anything or do any kind of embedment into another wall type. If I look at this in 3D, you can see that I still have the other wall there at the whole time. If I go back to level 1 and click on this particular curtain wall, I can click on edit type, and there's this option here called automatically embed. If I click on that, I now have this set to automatically embed in whatever wall I want, and then I can go ahead and look at this in elevation and divide it up and make any kind of design that I'd like to do with that component. Now the difference between the curtain wall assembly and the storefront is the storefront assembly has a set of parameters that give it a way of repeating when the mullions get drawn. So it actually draws the mullions for you as you're drawing, which I actually don't like because it's dictating basically a grid pattern that's going to be equal all the way throughout your design. But you can go back here to architecture, but there are a couple advantages of that, and I'll get into it here. We can go to storefront, and this time I'm going to draw just the storefront, whatever the default happens to be. And I actually should have changed my... It always remembers your last base offset and unconnected height. And change my base offset to 0. My unconnected height, we can go back to, let's do like 10 feet. So just draw a line, doesn't matter where it is. You notice as I drew that, it automatically placed mullions and glass and all kinds of things as part of Revit, or as part of that component. If I look at this in 3D, here's the component that it created, and maybe I should make this more like 15 feet. Actually, let's just be dramatic and make it 40. There you go. So basically, as I added and changed things to this wall, and I could even change it after it's been placed, it adds and takes away mullions and so on. Probably didn't want to do that. Control Z will undo things, by the way. But it basically added a grid of mullions and so on for this particular unit. That's because when you click on storefront and click on edit type, notice there's vertical grid and there's horizontal grid, and then there's mullions that are automatically assigned to it. Remember that mullion that we made before? If I click down, I should be able to find the 2" by 6" that we already made that's part of the system. So we could actually select all of those to be placed. But it's basically dictating what our different grid layout's going to be. So I could actually change my vertical grid maybe to, let's do something like 8 feet. And my horizontal spacing, maybe that one's more like 4 feet. And you can change if it's a fixed distance, maximum spacing, and so on and so forth. And we can go ahead and click OK. What that does is it automatically changes that around. One thing that's kind of nice about the storefront system is because it's on a grid system. That's the one thing I don't like, it's on a grid system, but one thing I like about it is because it is, we can click on it, and off to the left, we could change the vertical grid and the horizontal grid to have other different properties. I could change my horizontal grid to have an angle, so I could type in 20 degrees, and start to kind of change the direction of our grid layout. I'll do the vertical at 20. And you can kind of come up with, obviously, other different designs and patterns to your curtain wall system. Another component to drawing walls, and I'm spending a lot of time on walls because that's pretty much where you spend a lot of your time. That's the 3D component that takes up your exterior shell and your parts of your floor plan. We're going to move on to floors and roofs here in a minute. But the last component is everyone who gets this far in Revit starts to wonder, well, can I make walls where they slant in section or have different profiles to them? They're not always rectangular. Maybe you want them to, step or have some sort of angle to them or have other design features that are a part of them that actually mimic the customized design that we're trying to achieve in our own personal design model. And when you see these tools so far, you kind of get stuck in that you can only be in this particular environment of only having walls straight up and down. We can actually model walls to another component, and if you click on the down arrow under walls, you notice there's this option here to model by wall face. So walls, the architectural walls and the structural walls, I didn't talk about the structural walls because we're not really getting into structure, but basically those are the same thing as architectural walls, what we've been drawing with. They just happen to have structural information embedded within them, so it's not that important at this moment. But the wall by face is basically a wall that can take on any form based on some kind of underlying mass. And so in Revit, we can actually model a mass and then apply a wall component to it and get our desired section or our desired kind of form to it. Now I'm not going to get as crazy as what we see here, but just so that if you wanted to angle something in section or do something a little bit different, you have that freedom and capability of your design. I'm going to be in a 3D view. I'm actually going to delete this thing because I don't like it. I'm going to go into that 3D view and off to the right here. If we go under massing and site, there's this option here called in-place mass. And this is where we can do a lot of intuitive kind of model making and kind of this clay design, if you will. You can kind of push and pull points and edges and come up with a solid point of geometry. If we click on in-place mass, just ignore that dialog, the warning that pops up. And we can just call this wall number 1 or wall slanted 1, whatever you want. And we're now in this massing mode, and we're kind of where everything grayed out, which means we can't select these other components. All I'm going to do is draw a line, and I'm going to draw this line kind of from this wall where I was just at. I'm just going to draw this out, whatever distance. I'm going to select this line and hit copy to the clipboard, which is over here in the middle. It says copy to clipboard, or you could just hit Control-C on your keyboard. And now I'm going to hit paste, but instead of just hitting paste, I'm going to hit the down arrow, and I'm going to pick align to selected levels and select level 2 and click OK. Basically all that did was copy all those contents that I had selected up to the level 2 datum. You can do that with any component in Revit. So a lot of people want to know how you can get something from the first floor to the second floor or third floor. You can just copy and paste components that way from floor to floor. Now I'm going to select both of those lines and hit create form, and that will loft. Oops, what's that doing? Pick the, it's hard to see there, but pick that right square. Never seen that happen. There's a little right thumbnail that popped up. That made it straight up and down. For some reason, it's trying to make it into a cylinder. Anyway, so I've got this little mass wall that I can pick the edge, and I get these little coordinate systems, kind of like you see in 3D Studio Max, where you move them. I can pick the tab over and pick different parts, so I could actually pick the end point, kind of come up with these other parts of the wall moving back and forth. I can also do the same thing with the edges. I'm not going to get too far in depth with that, but I'm going to pick this line at the top now, and I'm going to move it out just a little bit to give it a slant. And now I'm going to finish the mass. So basically, in order for Revit to work in this environment and have the wall move out of normal, which means move out of perpendicular from the ground plane, we basically need to have this massing underlay. So I can click on architecture, wall, and then wall by face, and then I can pick whatever wall type I want. And I'll just go back and pick generic 8 inches, and then apply it to that wall, and then you've got that wall type following that particular mass. So in order for that to work, those masses need to be kind of as this underlay, and then you can just apply those particular wall types to that. Let's talk about floors. Yeah.
Can you go through there's a few people that missed the loft.
Oh, sure. Yeah, that loft command, for some reason at the end there, got kind of crazy. Let me go back to 3D. So I'm in the massing and site in place mass, and I'll go over to this other side. So you can draw a line, and this one I'm going to draw where I'm on the level 1. So in my options bar, placement plane is level 1, and I'm just going to draw a line. And then I took the line and I did a copy and paste. And with the down arrow, I did a aligned to selected levels, and I picked level 2, which is the next datum up, and that placed that line on top of one another. Now, I'm not sure why it's giving me these other little thumbnails, but if you select both of these, if I select one from the bottom and hold in the control key and select the next one and hit create form, it's showing me these 3 thumbnail buttons. Pick the last one. I think there's supposed to be some kind of picture in there. Just pick the last one and it gives you the way it should be, and it should have lofted those together. It actually works a lot better when you have 2 curved surfaces and it lofts really well together. Not sure why it was doing the little cylinder. But once you have that, you can pick that edge again, and then you can move these components. And then once you finish the mass, you have to exit out of this environment. That's when you can go back to the architecture and then place by wall face.
The massing tab, right?
You can either do it in the massing tab. There's wall face there. You can do it in the architecture wall tab there. You can also do it if you just pick the wall architecture, and there's this other icon here called pick faces. So it's actually kind of all over the place. One thing to note is that, I'm going to delete that one wall, is that the curtain wall system, so we did the storefront. If I pick the storefront system, and I pick face, and I pick this item that's slanted, it doesn't work. If you're working with storefront systems and curtain wall, as soon as you go away from the normal plane, it doesn't want to use those tools anymore because it's got some strict constraints set to those. So if you happen to get to that mass environment, and you want to do something different with your curtain wall assembly, at that point you want to use what's called a curtain system. That's the next one over. And essentially that one works the same way as the storefront system. So if I click on edit type, you see where it's got this dialog box. I can change my grid layout. I'll keep it at the, I'll just do 5 foot. I'm going to do my curtain panel set to system panel glazed. Grid 1 we'll do 5 foot. Grid 2, whatever, we'll do 8 feet. And then we have to assign mullions to it. I'll pick that 2 inch by 6 inch. And I have to do that for all of those, or I could just select that whole thing, hit Control C, and I'm just going to hit Control V and copy this into all these other spaces. A lot quicker way of working. I'm just going to do this real quick so we can move on to floors. But because we're at a tilt or at some other design of that massing element, if you use curtain wall system, we can now place that by selecting that face and then hit create system, and it'll apply that to that face. One thing I need to mention about doors inside of curtain wall systems is that doors, even though they're walls and doors need a wall to be placed into, when you've got a curtain wall system, you actually have to place a door in a different method. And I'm not sure what the reasoning is, but these are kind of the steps that you have to go through to insert a door into this particular curtain wall system. So I'm going to go back and look at this in elevation. So I wanted to be in that south elevation, and I'm looking at this component right there. I'll take a 10-second break here or whatever, let people catch up. If you can, look at your, wherever you are, look at your curtain wall system that you made a while back.
If you're taking a break, would you mind helping me get my toolbar back? I don't
Oh,
know
yeah.
how I got out of that.
Yeah,
but-
so a lot of times what will happen is while you're working in Revit, your screen might change. There's this little icon up here. Has a little arrow.
Next to modify.
Yeah, if you click on that, it cycles through different ways of displaying
Oh.
your icons. And a lot of people will freak out, you know, when it changes. If you accidentally hit that and you see that your icons went away, you just have to cycle back through.
Okay.
The other thing is if your properties box or your project browser disappear, you can go under View and User Interface, and you can uncheck or check those components over there, and it'll bring those back. A lot of times, you know, those accidentally get closed out.
Yeah.
All right. So we want to be able to place a door into this particular curtain wall assembly. One thing that we have to note is what we're doing is we're basically have to frame where we want that door to be, because what happens is when we place a door into this, it stretches and fills the whole entire frame of the, you kind of basically where the grid is set up. No, this reminds me, I got some other editing tools for you here on the grid. If I tab over, notice when I tab through and cycle through, at first I select the mullion, and then eventually I can select that dashed grid line. When I click on that, that enables that temporary dimension. So I've got 8 foot 1 inch. That sounds about right for now. If I tab over this other vertical, I want to make sure that between both of these particular mullions, I want to have a, let's do 3 foot 3 inch center to center dimension. Basically what you have to do is size the door that you want based on the center line of the mullions. So if I want this 3 foot, actually I probably needed that to be 3 foot 2. (3'2" by 8 foot door that I'm going to put in there, or actually a 3 foot by 8 foot door. I'm sizing this to be 3'2" by 8 foot 1. And that's because I'm also going to delete out this bottom mullion. So if I click on that mullion and hit delete, I've now kind of framed where this glass assembly is that I'm going to eventually turn into a door. So what we can do is go to Architecture and Door. You notice that we don't have anything but a wooden door that basically came with Revit. So I need to load a family, so I'm going to click on Load Family and look at the folder here called Doors, and we should be able to find one here called Curtain Wall Single Glass. It has to be one called Curtain Wall in order to be applied into a curtain wall.
Where's Load Family?
So you need to be in the Architecture tab, click on Door, and then you can see Load Family off to the right. And then you'll get the, this, you should have your Imperial library here called US Imperial, and you should be able to find the families called, there should be a folder called Door. Does everyone have this? If you don't have this particular folder structure pop up, if you scroll down on the left, there should be a little shortcut down here called Imperial Library, and you click on that, that'll take you directly to your library. So scroll down to the Doors folder, and we're going to find Curtain Wall Single Glass, and we'll click Open. Now we're going to tab over until, and we're going to cycle through and hit Tab, and we're going to select that panel that we just carved out for that door. Over here where there's the Properties bar, hit the down arrow, and we should be able to find Curtain Wall Single Glass, and that will place that door inside of there. If we look at it in floor plan, you also have your door set in there, which now you can also change, your door swing and wherever it needs to go. One last editing tip about this curtain wall assembly, and then we're moving into horizontal assemblies here, is that if you want to make any edits to your particular curtain wall assembly, again, at any time I can draw another grid line, and then we can go ahead and place mullions and so on. I'm going to draw another grid line horizontal here. But we can also make it where if you click on a grid line, you get this option here called add or subtract, or actually add or remove segments. I could remove parts of this grid line by clicking on it and come up with other patterning or other patterns to our window design. So then I could actually come back through here and place our mullion where it's only at these particular components. You can also do that at any time by tabbing over. So I'll tab over this other horizontal one, and I can add and remove segments at any time. And sometimes if you have a mullion that's assigned to that, it just wants you to delete it, and you can start to carve out and make different designs part of your mullion assembly. So let's talk about floor plans, making floors, and making roofs. So that we're basically, the goal of the end of this workshop is you should have kind of this crash course of at least putting together vertical and horizontal assemblies and being able to then experiment from them based on, kind of going back to the video and reviewing and then practicing on your own. So if we go to the level 1, actually let's go to elevation. I actually want to make another floor plan because I know, maybe this particular building is going to be 4 stories in height. In order to have a floor plan, we have to have a datum line. So we have to have one of these datums. We got level 1 and level 2 that came with Revit. But what we really need to do is add in another one. So if we click on architecture, and off to the far right, there's level datum. If I click on that, I'm just drawing a line that's horizontal, and I'm just going to draw it above from one side to the other. I'll draw another one after that. You'll notice as I get towards the ends of the other datums, it tries to lock or align to them. That's kind of a common thing in Revit. It will try to align to particular things. And as I added more and more datums, notice your project browser grew. You now have level 1 through 4 showing on here. I can then come in here and change this, so I have different floor to floor heights. I'll set level 3 to 28. Then I also want this one to be 14 feet apart, and so on. So as many floors as you have, this is where you'll start to add in your particular datums. And then again, these are tied to your project browser. Let's go ahead and draw on the level 1 floor plan. And we've got kind of something to draw around. We've been drawing this little bit of a boundary here. The floor command and roof command and all your horizontal assemblies are right here. There's roof, ceiling, and floor. It's in the architecture tab, and it's right after components and columns and so on. The floor, if you hit the down arrow, we've got a couple different types of floor assemblies. There's the architectural, structural, and floor by face. I'm not going to get into the structural, but the architectural and floor by face are 2 items that we want to talk about. Under roofs, we have similar items where we can do roof by footprint, we can do extrusions, roof by face, and so on. So the floor, if we just click on architectural floor, you should get this box that, or set of commands that show up that talk about drawing the floor by creating a floor boundary. You should see that up at the top. And we've got our draw command. So basically all we're doing is drawing the outline of where our floor is going to be. We can do this a couple different ways. I'm going to use my walls. There's this little pick walls command. And I can tell it to essentially pick my wall and then draw a line. So it's basically drawing to the edge of that wall. And just go around, and if I have walls drawn, I can go ahead and do that. Or I can just draw with pick lines or just a regular drawing command. And I'm going to go ahead and just trace what I have already. I'm just going to draw the boundary of where I want this floor plate to be. Now this component, or whenever you'll notice we've got this purple line, and the wall has, or the model environment has grayed out. That means we're in this sketch mode. And we basically, anytime you're in the sketch mode, whatever you're sketching has to eventually come to a closed loop. And I can go ahead and do whatever shape you want. Come on back. And to make sure you come to a closed loop, I like to kind of end short, because sometimes you might not snap correctly. And use this command up here called trim and extend to corner. And that is, you just select the parts you want to keep, and it'll trim and extend to make sure you have a closed loop or a closed line. Revit will let you know, it'll yell at you. For an example, if I have this overlapping, and I try to close out of this sketch, it'll tell you have overlapping lines. Just hit continue, and you know that you have to go back. Same thing if you have not a closed loop. And I close out of that, it'll show me that I haven't closed those. So just pay attention to those error messages, but a lot of times if you just do trim and extend to center, you can go ahead and close out of that. Now again, floors work just like walls. We're drawing with a generic 12-inch floor. Same exact thing that I talked about with the walls. If you click on edit type, you have the edit structure where you can go in there and change the depth of the floor. So if you know you're going to have 6-inch floor slabs, or whatever your floor assembly is, or just in generic terms while you're modeling, you want 1 foot depth in your section, that's where you set that particular component. Obviously you can add more and more layers, just like the compound wall, as you get more and more information. We'll keep it at the 1 foot for now. And again, we can do the same thing where we click on edit type, we change that coarse fill pattern so that eventually when we cut our section, everything, the walls and the floor, will be a solid black. Now we can just go ahead and click, well, I've already closed out of that. We can look at this in 3D. And now we've got that horizontal assembly. And let's say we want this floor plate on, and we know that's going to be the design on all 4 floors, which we probably don't want, but for instance, this particular building is going to be repetitive that way. I could click on this particular component if we're in 3D or in the level 1 floor plan, and let's hit copy to clipboard. And now we can do the paste with the down arrow and select align to levels, and now pick level 2, hold in the control key, level 3 and level 4, and click OK, and it'll copy that floor pattern on all the other levels. So it makes a kind of a quick way. A lot of times, if you're working, a lot of people will probably design their floor plate first sometimes, trying to figure out what the overall shape of your building might be, and then you can copy those up over and over. Or you could also, let's say you have, let's go to level 2, type in ZF to zoom to fit. I'm going to draw another floor plate on level 2. You'll notice that I can kind of see through level 2, and I can see the underlay of level 1. That's because on my level 2 floor plan, the underlay here is set to level 1. So you could have different underlays, so you can try to align what you're looking at, or I could set that to none so I don't see all those other items. So again, I'll have level 1 here so I can have some frame of reference of where I'm drawing. Let's go ahead and draw another floor. And this time I'm going to kind of draw something similar, but I'll make it a little bit different. So I'm draw around this exterior. Zoom in around here a little bit. And I'm going to come off this top piece and just do something a little bit of a different shape. Now we can also put a hole in a floor by one method is if we have a boundary and we've made it closed shape, whatever you do in the middle will be some kind of inscribed shape. And that will now be a hole cut out of that floor. And I'll just tell you guys that when you guys work, just play around with these different commands for drawing. Basically they're typical Rhino and CAD drawing methods. So you've got your 3-point arc command, you've got your center by arc, your rectangles and circles and so on. I'll hit the checkbox and close out of that. Whenever you're above a set of walls or a set of components, sometimes Revit wants you to automatically connect those walls to the bottom of the floor. I usually say no because we can do that ourselves later. But if I go ahead and hit yes, what that did is it trimmed. Remember we had these walls that were going up to the level 2 datum. We just placed a floor that was 12 inches thick. And so that basically those walls have to be trimmed down to the underside of that slab by 12 inches. So basically that's what this particular command just did. It made that attached. And of course if we move our datum up and down, those walls would still stretch with it. So let's say I have those 2 different floor plates and I know I want these to alternate from floor to floor or so on. I could also select this one floor. I'll hit copy to clipboard, paste to aligned selected levels, and this time I'll just pick level 4. And I'll do the same thing with the other floor plate, but this time when I do the paste, I'll do level 3. So anyway, you can start to model and do things that you need to up there. That's essentially it with the floor slab. The other component to the floor slab, and I'm going to make one more datum here so I can show you that top piece. I'm going to create an architecture level datum. Draw that so I'm up on level 5, and I'm going to copy that in 3D. This larger floor plate up to the top. So paste, align, selected levels, level 5. When I click on a floor, at any moment if you decide you need to change that because you've already kind of exited out of this component, you can click on this object and you can click Edit Boundary. That'll take you back into that sketch mode where then you can modify your design. You can also click on the floor and you have other parts and pieces here. So you've got modify sub-elements and add points and so on. You can also click on Edit Boundary. I'm going to go into level 5, floor plan, and you get this option to slope. So I could click on slope arrow, and I could say that this floor assembly is going to slope slightly. Let's say you're making this floor kind of like a ramp system through your building or whatever. When I draw that slope arrow, when I click on it, you have a set of parameters here where I've got the is basically level at the tail is set to the default, and height offset is at 1 foot, and level at head is at 0. That's basically in relative to the datum of level 5 floor plate. So basically it's saying that at the tail of this, that's where the 1 foot's going to be. I'm going to make this a little drastic so we can see it, and just say 10 feet. When I exit out of that and look at it in 3D, you've got a sloping surface. The other thing we can do is I'm going to Control Z out of that, just to go back. I'll look at this at level 5. I can add a point. So if I add a point to this, and I'll again just be a little bit drastic here and not too careful. As soon as I add a point, I can hover over it and select it again, and I can modify the sub-elements. When I click on that, I can change what the elevation of that point is. So I could actually, again, I'll go to 5 feet. And then I can look at this in 3D, and I've got another surface here that's, got kind of these push and pull points that are assigned to that particular point. So I could add as many points as I want. I can make them go negative. I can make them go positive. And the last thing with floors, back at the level 5, And if you don't like what you've done, I've added those points, you always get this option to reset your shape. So if I click on that, it goes back to that default where you started from. Another thing is I could just add a split line. And so this would be drawing a line, somewhere from one side to the other. And the split line works the same way, where if I click on it and modify the sub-elements, I could change this and look at it in 3D. It's not that pretty, but you get the point. So you can start to manipulate your ground plane, your particular floor plan by these kind of points and parts and pieces, and it's going to define as best it can by triangulating your surface and trying to connect those other points. And at any moment you can pick these other points and then also assign them different heights and so on. I'm going to delete that and keep our level 5 datum. I'll hit save. Always like to make sure I'm still recording. All right, so that's pretty much it with floor plans. I'll let you guys kind of experiment and not floor plans, floor plates. But what I want to do is go over actually working with the roof assembly, and then what we can do with the roof assembly, which we can do similar things that we just did with the floor, but we can also get into things like sloped glazing and get into skylight systems that mimic what we just did with the curtain wall systems. So I'm going to model on level 5. So if you don't have a level 5, or if you can model on your top level, again, your roof plan or your roof component is going to need some kind of datum to be assigned to. So I'm going to go to level 5. And I want to be able to see, since I'm drawing a particular roof that's going to cover our entire building, and right now all I can see is level 4, which is the floor plate below. I want to be able to see all the way down through my level 5, all the way down to the ground, so that I can actually draw a roof that would cover everything. So if I'm in level 5, over here in the properties bar, I'm going to scroll down to view range and click edit. I'm going to change everything for the bottom and the view depth. I'm going to change all that to unlimited. Everyone see how I get there?
No.
Project browser,
Okay.
click on your level 5, go over to properties, scroll down, and you've got view range, edit. And then I'm just doing bottom unlimited, level unlimited, and OK. So now I can see at least everything all the way down to the ground, which obviously if we're drawing a roof plan, we might want that kind of reference.
I have a question.
Yes?
What's the difference between the primary range and the view depth? The primary range, if I change that to unlimited, it gives me an error.
The primary range. Primary range is everything top, cut plane, and bottom. You have to make sure that your view depth and your bottom are both set to unlimited. If it's yelling at you for some kind of error message, you might want to pick them in a different order. So I picked bottom first and then view depth. So I believe the view depth always has to be either above the bottom or below the bottom or something like that. Otherwise, it gives you an error message. I usually just change everything to unlimited, and you don't have to worry about it. It works out pretty good. So now with the roof tool, we've got this option here. When you hit the down button, we can actually draw roofs by a couple of different ways. Again, by face, extrusions, and by footprint. You do the same thing that we just did with the floor plan. We can do roof by footprint. And this is exactly the same, kind of the same tool that we were just in. You can see the boundary lines and then the slope arrow. I'm going to go ahead and trace kind of this outside floor slab, and instead of picking each of the lines, if I hit the pick lines command and hit the tab key a couple times, it'll find the boundary of that floor plan and go all the way around. Sometimes it does, sometimes it doesn't. If it doesn't, you have to go around and individually pick each of your parts and pieces. I'm going to go ahead and straighten out this one piece over here on mine just because it looks a little like it would be a little crazy. You'll notice a little bit of a difference here is that when we draw these boundaries, we've got these little triangles everywhere. If you're familiar with kind of the international symbol for roof slope, that's basically, oh, I don't know if it's international, but at least the United States symbol for roof slope. It's basically the rise and run symbol showing you a pitch. So everything in this command is based on the pitch of the roof, so you can type in a 412 pitch, 612, and so on, and it's all based on that symbol. What that also means is that wherever you have a triangle, it is going to hinge, so you can think about it as this hinge point. From the base level, our base level is at level 5. When I pick this line over here off to the right, that line is at the 0 mark of level 5. And now, because of the hinge symbol, it's going to hinge up, and it's going to keep going until it meets the rest of the roof assembly all the way around to whatever your setting is. So by default, it's something like 912 pitch, so that's fine. Let's just go ahead and hit the checkbox, cancel out of that, and then it's made your roof assembly, and just put that together real quick. So obviously we can go around and make all the different types of roofs we want. If you want a hip roof, gable roof, not too exciting, but it gives you that option. If you don't want every single thing to slope, if you click on the edit footprint, you just tell Revit that certain components aren't going to be a hinge. So I can pick on this line over here to the left, and in the options bar it says define slope. I'm going to uncheck that. And now when I hit the checkbox, I've got this other end over here, kind of the gable end. Now, one thing with sloped roofs or sloped components, and let's do something a little more architectural here. I'm going to take all of these, turn off the slope, and let's just make one of these slope. So I'm going to make that defined. And change this to let's do 412. So we just have a one-way sloping roof, which is a little bit better. So I've got this little roof here, and anytime we've got these components, whether it's a floor, and again, floors could also slope. Remember, we just went over that. But I also have this sloping roof component. Eventually, we want walls and everything to get trimmed to that component. We want it to follow the slope. So anytime we have our walls underneath, I'm going to have to extend this roof a little bit. In order for this to work, our roof has to overhang our walls that are underneath. It doesn't have to overhang completely, but it has to at least be on the outside edge of the roof or the walls below. Now look at this in 3D. I've got these wall types that I eventually want to go all the way up and then attach to that roof assembly. When you select a wall, you get these other commands over here called attach, top and base, or detach. If I click attach, is it going to ask you in the options bar, are you attaching the top or the base? So obviously if this wall was floating above this particular roof assembly, I could tell the base to attach and then get trimmed out to that particular slope. I'll just do top for now, and then I'm going to click on the actual roof assembly, and it will draw that wall all the way up and then attach it. What that means is that also because it's attached to that, it is now a parametric component that's constrained to it. And if I look at the north elevation, and if I were to move my level 5 up higher, let's say to 60 feet, that wall is going to stretch up with it. So anything that's attached will go ahead and move up and attach to that component. And we can do that with walls, and we can do that with ceilings, and we can also do that with floors. So walls can attach to anything that's basically horizontal, and it can ask walls can also attach to other walls. So if there's another wall above it, it could actually attach to that as well. So kind of keep that open as an option. You can have that for easy trimming. Another way to deal with walls that I haven't, the last thing that I think I need to go over for editing of a wall is I'm going to take this one wall and add it up to, let me make it large. Detach it. Sometimes when walls are attached to other floors, sometimes you do have to hit that detach button to get it to work. If I can click on any wall, and if I'm looking at it in elevation, so I'll go back to, I think I need to be in the south for this one. We can edit the profile of a wall. Again, you have to be in elevation view, so I can click on edit profile. And we're in this sketch mode just like we were with our actual floor plate and our roof assemblies. I can delete these sketch lines. I'll keep the bottom one, but I can go ahead and, again, as long as you're making a closed loop, I can make this wall into any shape that I want in elevation by kind of sketching it out, by editing the profile. So that'd be another option. You know, that'd probably be where, like, if you wanted a wall to come and close this slanted portion of your particular project, you'd probably draw a wall here, make it extend all the way up, and then edit its profile so it gets trimmed back. So sometimes we have to edit the profiles of walls and things like that to start to align with our different parts and pieces.
Can you go over that again?
The edit profile?
Yeah.
So, and we can do this on curtain wall. I'll go ahead and do this on the curtain wall assembly here. Let me just draw another one off to the side. Curtain wall. So in the previous example, I was looking at the actual solid wall and did that edit. I can do the same thing. You know, again, these are walls. I can do it on the storefront or any other system. All you have to do is look at it in elevation, then look at it, click on the wall, and then click on Edit Profile. You get the boundary line that then you can start to manipulate and change. If it's constrained, you can just hit
Click
Remove.
on that line? Yeah.
But you can click on it, or you can erase it and draw your own lines. And then you can, in this case, I'm just pulling these up, hit Remove Constraints. And then move out through there. So you can get a lot more freedom there, you know, looking at an elevation. And then also if you're, again, working in that massing environment, you can do that as well. All right. Any questions so far? I'm covering a lot, but I'm trying to jam-pack these sessions to make sure you guys are getting up and running. I think the next part I want to do is cover sloped glazing systems, and then also the roof by extrusion, because there's a little bit of tricks to that and what that exactly is. The roof by extrusion is kind of what it sounds like. We basically have to draw what we think our roof is going to look like in section and then extrude it to some particular distance. And in order to do this particular method, we have to have what's called a reference plane. A lot of times in Revit, we need different planes to model on. The level datums inherently are a reference plane, but sometimes we have to make our own reference planes to then draw, you know, somewhere in the model space. So what I'm going to do is look at my level 5 floor plan. Actually, I think I'm going to hide this roof assembly right now because I'm going to kind of draw this other crazy roof on top of it. To hide things in Revit, there's a couple things you'll need to know as you start modeling. Down at the very bottom, so See the little glasses icon? You have that on every view. If you click on that, as long as you've clicked a couple different objects, you can choose to either isolate those items or hide them. So if I hide them, I'm basically just temporarily hiding those out of view. Sometimes, obviously you need to get things out of the way so that you can see what you're doing. What that means being temporary is that when you exit out of Revit and then come back in, you will, everything will be turned back on again. If you want to permanently hide, and so if I want to get that back, I'm going to hit the eyeglasses and reset temporary. I could right click on that and click on hide and view elements, and that will take it away, and now it's permanently hidden and won't ever come back until you click on, there's a little light bulb command that reveals all hidden elements, and then I can left click on it and click unhide element. So for now, I'm just going to do the temporary thing. Do hide and view. I'll go into level 5. I'll do that in here as well, hide and view. So basically what I want is more of a curved roof or something different going across this whole entire model. And I want it to be I want the section, if I were to look at it in section, the section cut is going north and south, and I'm eventually going to want it to extrude east and west. So what I need is a reference plane somewhere over here that I can actually start to draw on. So if I go to architecture and reference plane, see that all the way to the far right past the datum area, I can draw a line, and I'm just going to draw this vertical line, and it'll be this green dashed line. In order to use this reference plane, we have to give it a name. So if you left click on it, you have just a property that or a parameter that you can enter in some information called name. Let's just call this roof extrusion. And once you've named it, we're now going to be able to draw on top of it. Everyone see how I got that reference plane? Was that a yes or no?
Yeah.
Okay.
Sorry.
All right. So
That's a sort of.
sort of.
It's okay.
So to do this little section design, all we need to do is look at this in elevation first. So I need to look at my elevation tab over here. I got this little tag. It should be our east elevation. And while I'm in that elevation, I'm also going to hide this other roof because, again, we're trying to draw something different. I'm going to use the roof, so click on the down arrow and the roof by extrusion. Here it wants you to pick a reference plane. If I click on the little drop-down menu, if we don't have any reference planes, we won't be able to pick anything, but now that we've made one and named it, we can pick our roof extrusion reference plane and click OK. And then it's going to want you to define, where is the level, where is it going to be, it's sort of its level datum. We'll keep it at 5 feet. Or 5 feet, level 5. And then I'm going to draw, I'm just going to draw I'll do this the start end radius arc command. It's really a 3-point curve. And I'm just going to draw something from here to here, and then draw the arc. Now in this mode, all you're really doing is defining the general shape, so it's just going to be a line. Because then it's going to take whatever that 12-inch roof assembly is that you're drawing with, or whatever roof component you've chosen, and it's going to extrude it down off of this. So now that I've drawn that, I can click Exit, or the checkbox. I can look at it in 3D, and then it has extruded this to some particular path. I think I'm not sure where it defined where it wanted to go, but I can just pick these drag handles and eventually pull to where it's going to eventually end up. So again, those could be any shape that you wanted them to be, and just as long as you can imagine it in section, you can extrude it through that command. So I want to go over kind of sloped glazing, which We kind of went over sloped glazing in a way when I introduced the sloped wall idea and working on the mass, and then we applied a curtain wall component. Sloped glazing is something that's actually found in the roof tool, and it's really for generating skylight systems and making roof assemblies that are all glass and basically mullions. They call it sloped glazing. I'm going to go ahead and make this a lot smaller. Let's move that over there. It's not my finest design work, but all right. I can bring back this other roof. And for now, I'm going to actually make this roof a flat roof. So I'm going to take out that slope. Now we can actually, before I talk about the slope glazing, we need to poke some holes through the roof. We can actually put openings. I talked about how you could put an opening in a floor assembly. We could do the same thing with our roof, just as long as you make sure you uncheck all the different pitches that would be part of that. Another way to make openings is we could actually, and I'm going to go into my level 2, we can create under architecture, there's this thing here called shaft opening. And if I click on that, this will be basically a shaft, kind of this void that gets cut out, and we define how far it goes from the level 1 to all the way to wherever we want it to go. I'm going to go ahead and pick on all of these different lines there. All I did was the tab, and then it eventually picked all of that. My shaft opening is going to go from base offset. I'll set that to 0. My base constraint is to level 1, and my top constraint, I'm going to do level 5, and then set the top offset just to make it go all the way through, something like 50 feet. Not too important here, but basically what I'm doing is I wanted a uniform hole cut all the way through, and if I tab over, I can eventually pick it, and I could manipulate where it is and so on. What's nice about that method versus doing that other method where I'm cutting or making that hole in individual floor plates is if I ever change the shape of this, let's say you're modeling an atrium in the middle of your project, if you model all of your voids in your openings by the shaft opening, you can essentially just edit the sketch one time, and then it will edit, wherever it cuts through, it's going to make that geometry change. So I could edit this by clicking on it and clicking Edit Sketch, and then kind of maneuver around and change it to whatever I wanted. So anyway, we've got this hole there, and then we want to be able to put a skylight on top of this. I'm going to go back to the level 5 floor plan, and let's look at sloped glazing. So under roof, let's draw a roof by roof footprint. You'll notice that when you do the down arrow here under properties, you have all these different basic roof assemblies, and then you've got sloped glazing down at the very bottom. If I click on this, this looks a lot like when I click on the Edit Type dialog box, exactly like the dialog box that happened to deal with the curtain wall assembly. Nothing's really defined, so I'm going to define a curtain panel. I'll click on checkbox and make that a system panel glazed. Now I'm going to change my grid layouts. I'll just do maximum spacings at 5 feet, both sides. And then we have to define a mullion of some type. We can go back to that 2" by 6" we made. And again, all I'm going to do is highlight this and hit Control C. And I'm going to Control V into each of these. That makes it a lot easier than having to constantly use this menu and scroll down. Just a little shortcut. And this works exactly the same way with the roof. I'm just going to draw a rectangle. We can have all of these hinges. We can tell it what the slope is. I'll just leave it at the default. And then when we hit the checkbox, might take a minute. Oh, my void We'll avoid assemblies cutting through everything, so I need to, let's make that offset off of the roof by 1 foot. So that shaft opening is going to basically cut through anything that's in its way, so you just have to be careful how far you extend it. And then I also want, looks like this is on level 5. Looks like it's coming down a little bit. I can change, where this sits. So again, you can use your same roof assembly, by changing the gable ends or changing the slopes. And every time you do that, you'll basically get these skylight systems that you can start to manipulate and work with. We can do the same thing with if it's a roof by extrusion. So here's that curved roof. I can assign that to that sloped glazing, and it'll turn that into a roof system that then also follows that shape as well. So again, if you can imagine anything that you want in a particular shape in the extrusion, it could either be a solid roof assembly or it could start to be these curtain wall systems. One last thing about curtain walls. I think I've said that a couple times, but I'm going to say it again. I'm going to go back here to storefront curtain wall. And let's say I'm drawing a curtain wall in plan, and I happen to draw this as a curve. Watch what happens. I'm drawing this as a curve. You can kind of see I've got some kind of point here. But it still remains a straight line. But if I hover over it, you can see the curve that it was trying to make. The reason for that, and I'm going to make an elevation view of it. So if I click on View and click on Elevation, kind of hover over until I can see that piece. Let's look at that in plan. Basically, because this is one large sheet of glass, Revit doesn't know that it's supposed to curve this piece of glass. If you really wanted a true curved piece of glass, you'd have to actually model that. But watch what happens when I start to divide this up with my curtain grid. So we've got all these different vertical lines. I can click through here. It starts to segment that and try to meet the curve of that particular unit. So what it's trying to do is, since it's a straight piece of glass, and this also is true if you're modeling in the sloped glazing, is that obviously you have to come up with some kind of segment that would kind of follow the curve, so you can kind of get it to look a little more like it's following the curve and a little bit closer. There's a little more advanced techniques to make it where the glass would actually curve, but that's kind of more in a later workshop or later on.
Would there be a way to analyze it?
Yeah, that's basically the advanced part.
That's
It's the drawback is you have to exactly know your radius or make your panel where it's parametric to follow radius, and then you have to set the radius depending on what you actually drew it as. So it gets a little disjointed there when it goes back and forth. But let's see. One last item I want to go over, and I'm going to kind of delete everything that's on my screen here because it's kind of getting bogged down. Yes. Yes. Go ahead.
I was wondering, I'm not sure exactly what you're planning on covering next, but
Yeah.
I was curious. These guys have been developing, sort of more massing model studies with chipboard and other media at this point.
Okay.
And I wonder if it might be useful to talk about how they would build those generic masses in Revit, using the, I guess the massing.
Yeah,
tool here.
the massing tools and
Right, because
okay.
they haven't maybe, not everybody has been thinking about the floor plates in the same way in order to build a mass, but it may be some sort of organization of masses or geometry that's representing the bulk of the building right now.
Okay, yeah, that's great. Actually, yeah, the one part about Revit is we can actually start at a very schematic level. So if you guys are working with these massing elements, and this is one of the things I talked about at the very beginning, is we can start to mass and push and pull and do these things that represent whatever models you're working in. but we can also tie them to some kind of schedule that we can actually report any kind of programmatic data. Are you guys working with any kind of program at the point, or
Yeah.
some kind of square footage?
Yeah.
So we can make that connection here today, and you guys can start to experiment a little bit with the massing tools. So one way of doing that, I'm going to cancel out of, or just close out of that file that we're in, and let's go ahead and go into the architectural template. We'll start a new file and sort of set this up so you guys can work in that environment. Other thing I'm going to touch base on real quick, are you guys working with the topography yet? Or site, or
Yes.
a little bit? Okay. Do you guys have any kind of site survey or some CAD file or something like that? Sort of?
Yeah, they should.
Okay. What I'm going to do, because that's a lot to cover as well, I've actually made because I always get asked this all the time, every single semester, is how do you model topography in Revit? And I've actually got a tutorial that I'm going to give you, I'll give you guys a link to, that you guys can just watch the video on how to deal with topography and bringing in those surveys, and basically Revit draws, kind of a massing model for you and so on. So I kind of give you this quick little, it's about an hour and a half little tutorial that should get you through some things. But so talking about what I call intuitive massing, and it's going to be a little bit of I think, an oxymoron, because they call it intuitive massing, but it's a little quirky at times. It follows more of the rules of kind of what you're more used to if you're working in 3D Studio Max, and even back in the day, Form Z. It's kind of that massing technique. A lot of people like SketchUp because you can quickly push and pull planes and so on, and cut things up and move points around. And SketchUp actually has the patent on that technology somehow, and so other programs can't really duplicate that, and so they have to come up with different ways of working with it. So that's what you'll start to see here when we work in the massing model. First thing I want to do is every time we get into the architectural template, we want to click on View and 3D View so that we have a 3D view that we're working with. And this is pretty much where you're going to want to model, when you're starting to look at your mass and what you're going to do. I'm going to click on 3D. And over here where it says Graphic Display Options, click on Edit. And I'm going to change my background, and I'm just doing this so it looks a little bit better, to Gradient, and click OK. Anyone used Vasari before? No one yet? Okay, so all right. All right, well, I won't talk about it. But basically, Vasari is this version of Revit. So those of you that eventually use that in another class, it's basically this environment. Yep.
So you're getting a head start.
So under massing and site, this is where you will start to use your massing tools. Just like we did with the slanted wall and working in with that particular component, we want to click on In Place Mass and just hit close on that little warning. And we can name this whatever you want. Let's just say Conceptual Mass number 1. And so now our toolbar has changed a little bit at the top. We've got different tool tabs. This is what's called the massing environment. It's actually kind of this family mode or component mode. But the way that this environment works is a little bit different. It's about visualizing kind of the end points or maybe different profiles through your mass and then lofting them together. And that's basically kind of the concept of making the mass. So if we were to, let's just make a very basic one like a cube. I'm going to click on rectangle, and let's just draw at least something like at least a 30 by 30 rectangle or something like that. And I'm going to take this, and again I'm going to I could draw another rectangle, or I could copy this and paste aligned it like we did the other part of the project or the tutorial. I'm going to go ahead and just go to level 2, and I'm going to draw a different shape just so we can visualize a different way of kind of pushing and pulling these parts. I'm going to draw let's just say another rectangle that's a little bit bigger, and we're on level 2. look at that in 3D. So basically you have these wireframes that are basically the top and the bottom of this particular mass. If we select each of these, so if I select each one, I can hold in the control key and hit the other one, we can hit create form, solid form, and it will make a solid. At this point, this is where it starts to become the intuitive massing, is we can tab over different parts of this model. So I could tab over until I can only select that top face, and I can push and pull, and it's going to give you at least dimensional data, with those temporary dimensions. So at least while I'm pushing and pulling, I know that I'm, modeling to some sort of scale. If your project requirements are, this mass can only be, 50 feet high, maybe I want to be at that height. I can pick different parts of the mass, so I can tab over, so I can pick the line or that edge. I could also kind of move this out and about. I could also hover over and find the endpoint, and I can kind of pull and kind of move these over and over. And you could actually type in actual dimensions if you wanted to. They're all going to be based on some other endpoint. Usually when you're doing kind of intuitive massing, you're just trying to be in the general range of the scale of your object, unless you have specific requirements. Another thing we can do is we can click on the mass, and there's this option up here called X-ray mode. If I click on that, it basically goes to these purple outline, and it also shows you the endpoints of the different parts of the mass. What's kind of neat about this is I'm going to tab over that face again. I'm going to kind of make this a little bit higher. Again, I can push and pull these points by tabbing. And you're just kind of, bless you, kind of playing around with all these different parts and pieces.
Jeremy,
Yes?
do you know how it's resolving that top face right now, since it's not a planar surface anymore?
It is always lofting. It's basically interpolating what this form has to do in the loft in order to get to the next edge.
Right, so the vertical one will be a ruled surface, right?
Mm-hmm.
But the top one is a warping plane.
Yeah, it's warping.
Yeah, but so would it will leave it as a NURBS surface at this point?
Right.
Not triangular.
Yeah, it's all kind of NURB modeling
Okay.
in this intuitive massing.
Okay, good.
And it'll be the same thing too when you eventually, if you were to apply like a roof to that warped surface, that roof would follow that exact curvature and won't triangulate, kind of like you would normally see kind of in maybe like SketchUp.
Right, exactly.
So another thing about this is, we could start to divide this up and come up with other ways of pushing and pulling the form. So I can click on this mass, and there's this option here to add an edge and add a profile. If I add a profile and hover over the edges, it's showing you all the different profile section cuts, interpolated between the base and the top. As I add more of these, so I could add another one, I get more push and pull points to this particular mass. So now I can start to, even modify this even more based on, whatever shape I'm trying to make. Obviously, I'm getting a little bit crazy with the form, but you can start to see that it's constantly trying to loft between, and in this case, it's lofting between all of the profiles to try to make that spline or that NURB surface work. Same thing with the edges. Edges work in the opposite direction. So they'll work in the vertical. As I hover over, I can get an edge that I can work with. And you can, again, start to divide this up as much as possible and push and pull. Once you're out of that X-ray mode, so I can click on that mass and just uncheck or unclick the X-ray, kind of come back to that element, and we've got that particular component. Another thing that we can do is when we're in this intuitive massing mode, what we're thinking about is we're thinking about a mass first, and then also ways of pushing and pulling it to make a solid geometry, but at the same time we can make void masses that can start to cut out and kind of be this little stereotomic way of working where we're starting to slice and carve out different parts and pieces of this particular mass. We can draw as many of these masses as we want, so I could...
Could you hear me?
Yeah.
I'm sorry, I keep interrupting you, but when you modified that vertical edge profile,
Yes.
and this is, particular to the way I tend to model, it looked like the curve was an interpolated curve through the points.
Mm-hmm.
Is there a way to change that to
Kind of straight.
well, either to be straight, so that it is, a 1 degree curve essentially,
Mhm.
or can you change it to, say, a Bezier where it's using control vertices rather than? I mean, I'm not familiar enough with Revit to know.
Yeah, and with this, you can make your own curves that would follow those particular rules and then loft those together.
Sure.
But when you start to push and pull the points, it's all kind of free form.
Okay.
However, that does bring up a good point is if I click back on this and hit the X-ray mode, while I'm pushing and pulling all these points, I may not really want my slab or my facade and all that to look this way. I might really want it to be a loft from one profile to the other, and the other, so that it's more about straight edges instead of this kind of free-form blob that's starting to occur. And so what I can do is I can click on this, and if you click on Dissolve, it'll leave all of those profiles that were part of that original shape. And then I can click on individual ones and click on Solid Form. Okay. And do the same thing as I model up. And then I have kind of more expected, lofts from one part of your model to the other. That was weird. Oh, I didn't select the other one. If you just select one of these profiles and hit Create Form, it does a straight up extrusion to surface normal. That's what happened there. I forgot to hold in the Control key, so I got to tab over a couple times. There we go. So anyway, you've got those type of options. The other thing I'm going to do is I'm going to draw let's just be a little more basic. And I could draw a rectangle. Looks like I drew that on. I'm going to change my placement plane in the options bar to level 1. And I'm going to draw just a rectangle. And if you want to just start out basic, you can also just take your profile edge, click Solid Form, and then it extrudes up into a basic box. So obviously not everything's going to be twisty forms and all that type of stuff, but you have that freedom to come up with those different shapes. You could also create what's called a void form. So I'm going to draw just another rectangle. Let's go through this. And this time when I extrude, instead of picking the create form, solid form, you can create void form. And that'll be the same thing. It'll make this this kind of object here that I could kind of manipulate, move down, and it'll cut out wherever it happens to pass through. Sometimes, and every now and then, you have to tab through to eventually select that form. I'll tell you right now, sometimes the void doesn't always cut an object, and if that ever happens, and I can't always replicate that, you can select under Modify. There's this little option here called Cut Geometry. So right now I could actually do it in reverse. Let me do Uncut. Well, that took it away. Select the solid geometry first. Oh, well, maybe I can't do it in reverse. But sometimes you have to do the cut command where you have to select the void and then the actual solid component, and it will kind of cut that void out. Now, one thing about this is that if you have these void forms, and I'll just keep those modeled as they are, once you're done, you can hit finish your mass. And what I want to do is, in order to start to check this against my program, I need to have what are called your different level datums or your different floor levels. Those need to be set up so we can start to make what's called mass floor areas or mass floor slabs. So if I know this is going to be maybe a, I don't know how many story building, let me go ahead and I'm going to delete this level. Let's make this 15 feet. I'm going to use the array command. I'm just going to make as many levels as I can just to cut through this as an example. There's a little command here called array. If I select the level 2 datum and then click on array, it's just like in CAD where I can select the first start point, then I'm going to select how far it's going to go, 15 feet, and then I'll say how many times it's going to repeat, maybe 15. And click on enter. I thought I did 15. So now I've got too many there. And that one's probably too short. So I've got, anyway, these floor plates that are going to cut through all of these different masses that we've been working with. As long as we're in this, we finished our mass and we're in this environment, I can click on this mass, and at any moment, now that we're out of the massing mode and we've set up all of our datums, you can create what's called mass floors. So click on mass floors, and it's going to bring up this dialog box that's going to tell you, well, where do you want a floor to actually be created? In this case, I'm going to just select them all and checkbox, and then click on the exit button. So I basically made these horizontal cut planes wherever the datum is located, and it's showing you what that floor slab is going to look like cut through that particular mass. Now, if you wanted this, let's say I have different massing, maybe there's 3 different masses as part of my design, and I want different floor slabs to end up in each one, I would have to model this as a separate floor slab or a separate mass, exit out of it, then start a new mass and model this one, and then you get free range to decide which floor plate goes where. But by having that information, we can now extract some of the parametric data out of this that allows us to check our work. So at the schematic design level, if you have a program and you have to be X amount of square foot, this is where the kind of the power of BIM starts to come in, is we can set up a quick little mass area schedule that will constantly report this information back to us as we just kind of push and pull points. So I'm going to hit save here real quick. So to set up a schedule, basically what we need to do is click on View, and this is going to be up here at the kind of the middle top. There's this item here called Schedule, and we can do schedules and quantities. A schedule in Revit is basically a way of extracting a parameter. So remember I talked about how sometimes parameters drive the design of your components and what you're doing, and other times a parameter is a placeholder that eventually gets extracted for some kind of list or some kind of information to report back to you. So in this case, what you have to do is define, and this is all you're going to have to do in this case at the schematic level, is define what category you're trying to extract data from, because there's so many different categories within Revit. And so since we're in the massing mode, I'm going to expand that, and there's this little option here called mass floor. That's where we want to be. Since we've just made mass floors, that's what we want to report about. When I click OK, this is basically shows you the different parameters that are available for you to schedule. And over to the right is showing you what the headers of the schedule will be. So everyone's used Excel before. You've got kind of these headers at the top that will be named something, and then you've got a list of data. That's basically what you're doing, is you're building kind of this Excel spreadsheet that's going to tell you something. So all I need to do is I'm going to find the, let's call it level, because the level datums were what we want to start to extract the information about. And all I want to know, so I'm going to add that, and I want to know what the floor area is out of each of those. So that's all my schedule is going to be. I'm just going to add both of those, and I'm going to click OK. And it's going to show me, it's a little small there, but you can't really scale that, but it's going to show you level 1 through 9, and it's going to show you the square footage overall of your whole entire little massing study that you've been working on. You'll notice that when I made that schedule over in the project browser, it added it over here to the right. Now what's important about that is, obviously I don't have a total. Revit always doesn't total everything unless you tell it to. So what I've got to do is come over here to the mass floor schedule, and I've got these fields that I can edit. Don't worry about all these edit buttons off to the side, because they all take you to the same dialog box. You can see the same headers. But basically what I want to do is just sort this by level. I'm itemizing every instance, and there's a grand totals where I can do title, count, and totals, or I can do totals only. And the last thing I have to do is go under formatting, and where it says floor area, I have to click on the box here that says calculate totals. Once I do that, it now calculates that whatever I've just modeled there is 102,000, about 103,000 square feet. So obviously if that's your program square footage, you know you're kind of close. But what's nice about that is now that you've made that connection to this schedule, I can delete out of that, and I'm going to go back in and edit in place my mass. Not worried about that. And let's say I start to manipulate, how far this this particular void goes. Or let's do just start to play around with the shape again. So let's say I start to move this component around and move it down. Again, we're just, after we did that one study, we decided we wanted some other studies or form. When I cancel out of that, it updates all those mass floors to whatever shape you just intuitively, in quotes, kind of modeled to. But at the same time, when you go back to your mass floor schedule, it now says those changes now, for some reason, equal 124,000 square feet. So I've actually, even though it looked like I stretched it down, I also stretched it out and did all these other things. I'm now over my program square footage. And so you can keep this, where if I look at the view and click on tile, oops, I don't need all those open. I could model with this split screen view, and at the same time as I'm modeling, I can constantly keep track of all of my data that's talking about my floor area. So that's kind of the basics of the intuitive massing, and there's really not a whole lot more to it than that, except that you just keep either taking away voids or slanting things and kind of moving them around. You can also, again, everything that you do that wants to be a mass floor area schedule or be part of that schedule, it has to be a solid geometry. So those walls that I started at the very beginning, or towards kind of the beginning of our tutorial, where I slanted and I just used a line to loft from one to the other, those can't be calculated in the mass floor area schedule because it's not an actual solid. So just keep in mind that it has to be closed shapes. Yes?
Going with that, is there a way you can, where it's faceted, is there a way for you to, break planes that you can, peel something back?
So what do you mean?
If you go to the face that's inside between the two masses, it's got, the faceted parts of it. Is there a way to, break that surface so that you could click the edge line and, peel it back? So it's no longer exposed.
So like the floor plates actually are kind of cut out at the corner or something like that?
Or without even thinking about the mass floor, it's just, I guess it would be a massing model that would be more so. But just so you can peel the surface back.
Yeah, I guess I'm not, you can do it with void, you can basically cut it out with voids. Is that, so I'm not sure what you're peeling, how it's peeling back. But if you start to move an edge, it's basically going to pull everything with it. So the mass is always going to be kind of this solid geometry. But if you wanted something more cut out of the corner or something like that, you'd have to do kind of this void mask that would start to cut it out. So it might be a little limiting at times of what you're trying to do, but those are kind of the tools that you can work with. The other thing that you can do is you can actually bring in, and I can send you information about it, but you can actually bring in a Rev, or like another, like either SketchUp or a Rhino mask and have this applied to it and then cut it up. But there's a few different steps to get that done.
Yeah, that would be great for everyone, I'm sure. But I think that question is a great question to understand. I think what you're talking about more is like developing an architectural effect of the way the geometry and the space develops, right? So that might be when you transition from what is this intuitive mass to understanding how the building is assembled, right? So this intuitive mass is to give a basic sketch of where you're going to be with your geometry, right? And you can get some quick information out of it. But then as you develop the assemblies, the material assemblies, and you start thinking about those architectural effects where you might be peeling away surfaces that allow space to slip in a different way. I think that's developed from here to a more detailed level within Revit.
Right.
I would imagine.
Yeah, so that's a good point. So basically, when you get into that level of thinking of your detail of your architecture, you're back in the project environment where you're using those wall commands and the floor commands and all those other components, where you've kind of left this as a underlay to your model.
Does that make sense? So I mean, if you're familiar with working in Rhino, it's all sort of collapsed as one model. So you would start taking this and editing this and breaking apart the surfaces to start to develop the geometry and the spatial effects within Rhino or SketchUp, right? Because it's for lack of a better term, a dumb modeling environment, right? Revit, on the other hand, is expecting you to include a lot of information, hence the building information model. So as you move from this intuitive sketch, which is really a more dumb model, you need to start layering information in, and that information is in the form of assemblies, and those assemblies start to frame what the space is in the model, right? So it's a slightly different, in the software world, it would be a slightly different architecture, but for us, it's a different architecture for real. But so the way that you conceive of the model on two different levels is completely different than say Rhino or SketchUp, where it's all flattened into one space. Does that make sense?
Jeremy, could you use the same kind of technique that you used when you were trying to sort of use a surface as a forming device for a wall? Could you use this larger thing as a surface as a forming device for a wall, so you could actually just kind of begin to cloak the geometry?
So just like we did with just the one line that lofted, all of these mass surfaces can be picked so that an actual Revit object gets put onto it. So the idea about this peeling away effect, that might be where you would actually model another straight wall that shows that peeling effect, how far you want to go that's in that mass, and then you could apply your actual wall component to it and still leave the rest of the building there. But you could also apply it to this wall or any of those sides, or even the floor plates could also be extracted that way as well. So as long as it's a mass, it's an underlying element that your roof, any roof element, any floor element, and any wall element can be applied to eventually. So yeah, you could kind of cloak it based on that. The only downside to that is that when you apply any kind of floor plate or roof or wall to this mass, if you want to make an edit to that particular wall and you want to change its design or where it's located, you have to go back to the mass and make the edits there in the mass so that it knows to change and move with the mass. So once it's hosted to the mass, it kind of lives with it, and you have to go back to the massing element to continue to manipulate it. That is the only drawback to that method, but it gives you a lot more free-form options as well. And just one last thing here, once you're done especially in this setting, if you have a context or not. You can look at your mass and start to understand its relationship, to other context. If you had a context model in there, or site topography, and that will be covered in that video I'm going to give a link to. But another item here is you could also display kind of a quick shadow study if you want to know kind of like what's happening with the sun. All of your views have down at the bottom the sun setting. And when you click on that, you can turn on, and before I turn it on, I'm just going to click on sun settings. You can identify kind of a single day, multi-day, or just a still shot, kind of like a specific time or day. I'm just going to do a still day for now, which will cover sunrise to sundown. But you can also pick a location. As long as you're hooked up to the internet, it'll bring up Google Maps here in a minute. Maybe the internet's not working now. There we go. And we could type in, wherever you want. So I could type in, Charlotte, North Carolina, and set the place of where your site is. So you could set your specific address, and we can click OK. And now your sun diagram and everything is going to be based on this particular area. And then I'm going to do, just for now, whatever the default here was, 6/1/2010. Now when I turn on the sun path, it's going to show me that sun path diagram. And I can take the sun and I can drag it, to different positions and see what it's going to look like during the day. And if I turn on my shadows, which is right next to the sun, you can start to see, how your mass is, reacting to one another, and get a little bit of a sense of, the sunlight direction and shade and shadow. I think we're towards the end there. I tried to cover a lot of information. I know it's a lot, but that's the point of the workshop, is kind of this, here you go, here's a lot of information. I don't expect that you will just come out of here and start doing it, but I know eventually you're going to have to be doing bits and pieces of this in your studio. And so I'm going to make the video of this, of what we just saw here is going to be available. I'll send out a link that you guys can distribute. And basically you can revisit at times and come back to this and say, okay, now that we're working with walls really for now, I can go back and review that session. We're going to have 2 more big overall workshops like this, and I'll talk a little bit more in detail what those will cover, but we'll get into a lot more detail about how to make your walls more tectonic, looking at parametric reveals and sweeps, dealing with things like stairs and railings and all of those things, so that you're making customized objects and products and spaces, and not things that are default out of Revit. And then eventually talk about, I guess eventually probably more like construction details or rendering visualization techniques. There's all different topics that we can cover that will be part of those other sessions.
And because of our collapsed time schedule, we'll look again at the calendar just to make sure that if we stick with the original dates, we're only about a week and a half away from the second one. So use every chance you can to practice these things so that next time we're ready to move on with the next steps.
Yeah, you're at least familiar, more about Revit, especially if you haven't been using it. Like any software program, the only way you're really truly going to learn it is you have to actually do something in it. You can watch. What's it?
Yeah, dive in.
Yeah, you can watch as many tutorials as you want online, or the screens or whatever, but you're not going to really understand it until you start having to do it. So that's kind of the thing. Just do what you can and start, and then that'll also generate more questions. And I'll be available throughout, to eventually answer questions and things like that in the future.
Are you going to give us links to other tutorials, or are you recommending some tutorials that are out there that are not yours?
Well, I've got basically on our class website, or my building information modeling website, I do have a lot of different archived tutorials and classes that I can pick sort of pertinent ones that would be applicable to whatever you're looking at. So for instance, the topography one I'll send out. I do have on the website, since we have a little bit of time, I do have approved web links, which I give to my class. These are either websites and blogs that I follow. So these are the people that are actually using Revit that I kind of look at after and see what they're doing with it. There's a lot of different tutorials that are on those sites, but they're doing a lot more computational design and things like that. But there are places to find those tutorials. YouTube has a lot of information, but it's hard to filter through and find the things that you really want. So if there's a particular topic and you want a tutorial to find, I could probably recommend either one that's covered in one of my previous classes or one that I've followed before. Anything else?
So how many classes would it typically take to cover everything you did today?
This
This is not one day.
no, this is not one day because first of all, my class is only about an hour and a half.
Oh, okay.
And I do get into a lot more detail into each of the components. So like I stopped short on the walls of talking about the layers and adding sweeps and reveals. Save that for another time. This is probably I'd say the first 2 weeks of quickly coming through, and then when we're done with this, probably the first month.
For example, I want to make a void by shaft by using the shaft component, and then I want to add a bridge in the middle of the void. So I couldn't do that. As you see.
Yeah. So if you're using the shaft, it's going to cut whatever you put through it.
Yeah.
So what you would want to do in that case is you would take two shafts. You'd have a shaft at the bottom, one at the top, and the one that you want the floor to go through, you'd have to kind of trace out the floor plate, the opening, and that would probably be the best way.
You can't tell
But
it's
for
not
example,
Yeah, I'd have to play around with the shaft. I've never really done
Yeah.
that. Yeah, you could probably say don't cut the geometry, but I can't guarantee that yet because I haven't tried that.
I mean, I think you guys have seen this program is super, super complex. There's a ton of components, and I doubt there's anybody out there that knows the entire program, honestly. But some of the things I want to echo, I think that this was a great introduction to getting your feet wet, and really the best thing to do is just dive in and try, and get in there and mess around with things, sort of learn from trial and error. I want to stress again, don't use default systems, default assembly systems. If you think about, those were written by software engineers, right? Those wall assemblies. They probably consulted with architects to understand, where those positions were. But this program is written by software engineers, not architects. So don't rely on the software to design your assembly systems, right? You get in huge trouble. Maybe not so much in studio, but out in the real world, if you do that, because your liability is going to be tied to those wall systems and those wall assemblies, right? So make sure that you get in the habit of designing your own wall assemblies and systems, and don't rely on the defaults. Okay, the defaults are great to show you what's possible in terms of how you set up the layers and the layering of information. But again, keep in mind that software engineers wrote that stuff, not architects. Okay.
Right.
So you'll see it happen a lot. When your floor, and I think Jeremy referenced this, when you extrude a wall to a floor plate, the software engineers don't know what is the best way. Should the wall support the floor at that point, or should the floor support the wall at that point? Those are real fundamental building questions. And so you're going to have to make those decisions as an architect and not rely on the software to do it for you. And those are things that we're going to be talking about for this entire semester. All right. Great. Thank you very
Good.
much. That was
All right. Thank you.